Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Grabbing coffee, so let's wait a bit and we will kick it off. All right, I'm going to be a man of my word. 2 minutes passed, so welcome to the second day of the Rtc.On conference. Second and unfortunately the last day of this year's edition, but definitely not the last ever. I see the crowd is, there are less people than yesterday, a little bit, so I guess that the boat party went extremely well. I do not have any housekeepings. You know everything about those things already. So let's kick it off. There is a word in English that doesn't exist in Polish, and I love it particularly. The word is serendipity. And I think that last year at this conference, a serendipitous event happened because Cezary joined us as a participant. He didn't plan, but he did. And then we got to know each other. He started working at Stream. Stream is our sponsor. Cezary is going to be delivering a wonderful talk today about something that is rather difficult and, on the other hand, very interesting. So, Cezary, the floor is yours.
Thank you. Okay. It's the first time I'm presenting with glasses, so I'm not sure if I need it or not. But let's try. Okay, I'm Cezary Siłek. I have around 20 years experience in the RTC space. I'm working as a staff engineer at Stream. We're happy to sponsor the event. help community as well. And I'm currently taking care of our live streaming project and product in general. Trying to make it better. So, two shameless plugs at the beginning. I know the audience is probably not the right to promote our video products, but I actually had a few interesting conversations yesterday, mainly about whether to use like a ready-made platform or have something in-house, and it turned out there is still some interest even in our industry to use ready-made platform, which hides the complexity of video and audio as well. We also leaders in chat and chat moderation, so this is maybe something that you may be interested in. It's really a cool project. We have really many happy customers. We have few people from the stream here. We have Jose, Daniel works on Unity integrations for gaming, which is also interesting. We have Devin, who works on AI currently, also very cool stuff. So I guess you may approach them and talk about. Okay, and we are hiring. This is the link to our the job board. If you're interested, feel free to have a look. Golang engineers, WebRTC, SDK developers across every subject, basically. Okay, that's enough. Why 4K and 60 FPS and stereo? You may ask. Because customers started asking for it. That's the easy, simple answer. As many of the businesses are customer-driven, we react to what customers need, and this is one of the topics that came out recently. We did have increased number of requests for that. Okay. And why would you need it? In what use cases? It's paid content where you know, customers, viewers expect good quality, yeah. Also, some customers want to have it separated, have the video separated from other platforms for many reasons. Security is one of them, for example. Also, gaming. It's getting quite popular. It's not only for live streaming of someone playing a game, but also using WebRTC within a game. Live music streaming, small concerts. Yeah, we had many actually customers using it for that reason. Live auctions, you probably seen a movement in that. There is, we see the number of auctions being live on the internet is increasing, and WebRTC in particular is good for that because it's real time. You need very fast feedback on what's going on, and the quality is needed to show a product. You probably even saw eBay recently started doing live video for auctions when they basically show a product and try to sell it. Okay. Company events is something that came out recently. Many companies have few offices around the world. They have lots of remote employees. They want to get them together, probably have a large screen somewhere in the office with really good quality video. All hands. Many of those events have some sport-like competition, and so there is some fast movement. So that's why you need high quality, probably high bandwidth, and high FPS as well. And why WebRTC? There's plenty of other protocols YouTube never used, or not officially, WebRTC for that. But WebRTC gives very low latency, and we all know it. As I mentioned, auctions, e-learning, all the situations, the audience participation matters. We also been watching the mock movement, and we think it's definitely something that need to look at, and we are watching the space to see what's happening with mock. We will definitely come back to it at some point. And also the easiness to integrate with CDNs, it's also really appealing in that, which is quite hard for WebRTC. Okay, WebRTC is good for, it's adaptive to conditions, to bad network, to low performing devices, etc. So that's another reason. There's a good codec selection. Some protocols don't have it. The other reason why we use WebRTC is because we've got it. Our whole platform is based on SFUs, and it would be really bad to not use it. And it was obvious choice for us. And support for AI. Many AI vendors have AI integration based on WebRTC or something really similar to WebRTC. So that's one other point. So the story started a couple months ago when one of our customers came and asked, "Can you do 4K video?" And we said, okay, we had it in the plan. We knew it's there. It's not complete. I said, okay, we can do it. We need to do a couple of tweaks. It took us a week or two to have a proof of concept. We asked customer to try it, and they said they come back to us. Okay, it works, but it's only 30 FPS. We provide gaming or gaming-like content. We really need 60 FPS. So the 30 FPS was no go for them. Okay, and they also added, yeah, we expect to have 20,000 customers viewing the stream, which, you know, at that point, it started getting serious. So we needed to come back to it. We know it. They also added they need it in stereo, which is also not easy, and I'll come back to it later. Okay, so we started preparations. We had proof of concept. We know it worked. We know we can deliver live streaming at 4K. So the customers, the particular customer is OBS, RTMP, like most of the live streamers do, which means default H.264 and AAC for audio. So typically for the 4K H.264, you need to ingest video on the level of 10 to 12 megabits per second. We also tried lower bit rates, and it even worked. Even playing like Hollywood cinema at 8 megabits, it looked surprisingly good with H.264. So it was kind of baseline for it. Although for the 60 FPS, you need to double that. Yes, that's the basic. So the ingestion has to be on the level of 20 megabits per second, which is also quite significant. So, of course, it all depends on the content of the video. For the conference, like you may probably get away with 10 megabits. If it's a gaming, sports, or something like that, maybe 30 megabits per second may not be even enough. So just bear in mind. This is the ingress part only, so we just need to make sure that the ingress can handle that. The customer can handle that has a good internet connection, etc. Okay, the purpose of our ingress, as in many examples, is to receive RTMP, transcode the audio, because RTMP has an AAC, the standard RTMP, not the extended one. Receive the AAC track and transcode it to Opus. We also need to create simulcast, yes, because you cannot just assume that everyone will be able to receive 4K on any device at very high bit rate. So normally we generate 3 tracks, like in a standard 1080p, we generate like 1080p at 4 megabits and 720 at 2 megabits, 2 to 3 megabits, and probably 480 at 1 megabits or close to, or below 1 megabits. And this has been working for a long time. We never had any issues with that. Okay, so we need to decide what layers, what qualities we need to send it to customers. So first of all, which codec is going to be used in the direction to the customers, to the subscribers? What resolutions and what bitrate? So as I mentioned before, we've been using the H.264 for that for a long time, and it's been okay, but we want to explore other possibilities, such as VP9 and AV1, as are probably the best codecs on the market already at the moment. So we kind of selected video that we want to benchmark our what we can get for in specific bit rates, and it's one of the demonstrations of the NVIDIA RTX. Where's my? I'll show you a little bit. It's not really. So it's really challenging content, and I probably watched this video hundreds of times. It changed everything when we switched from like a normal movie to that. It's really hard to get a good quality on the streaming on that video. Okay, the standard tool for assessing the quality of the stream is it's a VMAF from Netflix. It seems to be industry standard, and it's open source, and it has a FFmpeg filter for that, which is really handy. So we started assessing it, and the first result we got was this, which is, it seems okay for VP8, VP9, and H.264 with the 0 latency flag, but AV1 always looked like that. And to be honest, we are not sure why. If you have any suggestions, feel free to to reach out to me. There is a special 4K model for assessing the 4K quality. So even if you tweak it, it may look like that. So it's still really bumpy. Also noticed the AV1 assessment is really hard. It really depends on how many cores you use. So more cores you use, lower quality you get. And it was no-go for us. We were getting completely unexpected results. We couldn't use it on one core because we have to be, very efficient. So we and by the way, the AV1 for the 1080p, even 60 FPS looked really good. So this is the expected result. This is what we would like to get for 4K as well, but it's not that. So we've decided it's probably a little bit too early for AV1 and VP9 for us, at least for now, but I'll also come back to it later. There are a few other issues with that as well. Maybe it's a configuration. Maybe it's us. But and to be honest, if you look at the graph, the H.264 it isn't really far from VP8. The VMAF score was always slightly better. However, when we saw the video, we didn't like it. It was for us, it was worse for some reason. Again, maybe it's just our configuration and parameters you can tweak for the encoding part. Also, transcoding for H.264 is really cheap. Although we receive H.264 and we spit out H.264 as well, we need to transcode it. We need to normalize bitrate. So we've noticed that transcoding with transcoding H.264 we can get over 150 FPS like in real time, while for a VP8 it was around 80, and it was single-digit number for VP9 and AV1. But again, it could be due to configuration. So we selected this H.264. Well, we decided to stay with H.264 because we've been using it. We know it works. It's being supported everywhere. It has hardware acceleration, probably in all the platforms. You may ask, why do we want to force a single codec since it's WebRTC? You can always renegotiate if it's needed. The problem is, if you have 20,000 subscribers on WebRTC, you probably don't want to renegotiate the codec. I wouldn't do it even for 1,000 subscribers, to be honest. But I'll also come back to it. So currently we support three layers, 3 qualities for H.264. Normally, what would you do? Would you, like a normal scaling factor, you would send for 4K60, then 2K60, maybe 1080p 60. But you probably would eliminate lots of potential viewers if you do it. It's too much for many devices and many of networks. So we ended up with this. So the highest layer at 4K60, then 1080p 60 FPS, and 720 at 30 FPS for the lower end devices that really cannot cope with the quality, with the bandwidth. Okay, so the typical scenario for us was that the publisher sends over RTMP. I have to probably add, we also support ingestion via WebRTC, but also come back to it later. So we have RTP We have the producer, our RTP to WebRTC gateway, and a bunch of SFUs. This is, of course, within a single availability zone. If we need another zone, we just create a new zone and we cascade it. And it seems to be working. This seems to be scaling really well for the qualities under 1080p, and also for video. We have customers, and we've tested it with 200,000 subscribers, for example. No issues. And we're also trying to avoid cascading as much as possible. So we started doing the maths for the 20,000 subscribers, having this kind of setup. And for 20,000 subscribers, each one receiving, of course, this is the worst case scenario. We assume everyone is able to receive 4K. So you probably need around 400 gigabits per second of bandwidth. Gigabits, yeah. Then, like typical EC2 instance is 5 gigabits, but you probably don't want to desaturate it. So let's say the 2.5 gigabits is a safe zone for that. So you probably need around 160 SFUs to handle that many customers. You have to have some headroom for the CPU usage. So this is only considering the bandwidth. If you look at this graph, it means you have to create a link between the ingress and each SFU. And each SFU needs to receive around 35 megabits because you need to send all those 3 layers to each SFU. So the ingress will have to handle over 5 gigabits of data, of bandwidth, and will have to transcode the traffic, which is impossible. So we modified our architecture to have 3 SFUs doing the load balancing only, and then the rest of the SFUs serving the customers. It's working. It scales up to the huge numbers at the moment, so we're good with that. PLIs and keyframes could be problematic because they just do propagate across the SFUs. So we need a way to handle that. So basically, if a browser sees a lost packet and lost video, it sends a PLI, and in most cases we need to or encoder has to regenerate the keyframe. And if you have 20,000 customers, viewers watching it, you have a high chance of receiving lots of those. So what should we do? We can re-encode on each SFU, but it's hard. As you saw, it comes with a huge cost. So we decided not to do it. It's CPU intense. Increases latency, of course, as well. So you can also rate limit PLIs to, I don't know, to reasonable number. So if you do it for, if you rate limit PLIs to, I don't know, 1 per second, you should be, we should stay at the safe zone. Of course, the downside is that customer may lose video for up to 1 second, okay? In the case of packet loss, huge packet loss. So I started playing. I wanted to have my own experience with streaming from a normal device. Oh, I finished time? Do I have much time? Are we okay? Yeah. So I selected the, I wanted to play with 4K cameras. It turns out they are not ready. The stereo, most of them claims they are stereo, they are not, they're sending 2 channels. And even professional setups struggle with 4K f 60 FPS. We have customers with the highly expensive gear, and turn out they need to upgrade their equipment to actually support 4K at 60 FPS. The stereo requires SDP munging, and that's the standard for now, which may be problematic. You probably heard about the local host tracking from Facebook. I think Google at some point we're gonna ban the SDP munging. So, but as for now, to enable stereo, you need to munch the SDP. The stereo doesn't work with echo cancellation and noise cancellation. You need to disable that. It works differently across all the devices. So we have a huge matrix of compatibilities and what you need to do on device, and if you need to do that on iOS and that on Android, it's not as easy as it seems. So is WebRTC good for live streaming? From our experience, it's good, but publishers tend to prefer RTMP, and we kind of agree with that. It's easy. You can detect if there are failures. They can detect. Sometimes with RTC, there is no much visibility. Yeah, RTMP, SRT give instant feedback. WebRTC needs a little bit more bandwidth to ingest because you need to send multiple layers. It's still good for publishing from a mobile device. What's next? 3 qualities are not enough. We're working on bumping it up to maybe 5. You saw our lowest resolution is 70p R30. It's you probably need to something between and something lower as well. Offer more codecs. As I mentioned, transcoding is expensive. You will have to probably transcode it and give customers selection of multiple streams with different codecs. It may be cheaper to do transcoding than offering and then spending more money on bandwidth. Yes, bandwidth is also expensive. But for that, we would have to have SVC support, and SVC, as far as I know, it's not fully implemented in GStreamer. As far as I know, it doesn't support temporal and spatial, both layers. We have also WIP, but it's also problematic for now. OBS doesn't support simulcast. There is a PR from Sean, but there is some oppositions against that. I don't know what's happening. That's all for now. Thank you very much.
Thank you, Cesare. I think that we will have time for 1-2 questions. Please raise your hand. Oh, okay.
Oh, okay. Thank you for the presentation. For PLI, so do you just rate limit, or do you cache like frames from last keyframe, or what do you do?
We just rate limit to 1 per second, I think, at the moment, per track, and it's good enough for us. I know, for example, MediaSoup has some transcoding gateways where they can basically regenerate PLIs on each SFU, but we thought it's overkill for us.
Okay, thank you.
This gentleman over there.
So, hello. Yeah, quick question. On the bandwidth estimation, I'd read somewhere that the bandwidth estimation for transport-wide CC doesn't really work over 30 megabits. Did you see that? Did you see that effect, or is that just a piece of gossip?
We haven't noticed that, to be honest. We're still working a lot on bandwidth estimation. We have like kind of dedicated person who work on it almost full time. It's a hard topic. Probably another presentation.
Looking forward to it.
Thanks for the presentation. You mentioned that you simulcast 3 layers. So it looks good for the customers who have very good bandwidth. But what happens when you have a choppy or a low bandwidth? So it really struggles when you have 3 simulcast layers.
Okay, so our lowest layer is 720 30 FPS at 1 megabit. If we detect that's not enough, we have to disable video track and then stay only on audio.
Okay, and then another question. So in case of live streaming, when you have a customer sitting inside an enterprise network, like say 1,000 or 2,000 users sitting behind an enterprise customer, and how does it work when you transfer the RTP stream directing entirely to the enterprise? So a CEO from US and he has an office in India where you have...
Oh, we have multiple availability zones. So if we detect that there are people joining from India or from US, we have data centers there and we cascade the traffic between SFUs, between the zones. And customers, each customer's, well, at least the customers watching it over WebRTC, because we also provide HLS and RTMP out, but the customers watching over WebRTC, I mean, each customer has to create its own peer connection and RTP stream.
Okay, thank you.
All right, let's wrap it up with the round of applause.
Thank you.
Don't forget to scan the QR code. And our next talk for the day, it will be returning Rtc.On speaker, Saul. Last year, Saul didn't make it. Boris Grazov came in and gave a wonderful talk. This year, Saul is here, and he also brought Razvan Purdel with him. This probably, as you know, based on the agenda, this day will be a little bit more AI oriented, so this is the first talk that's gonna kick off this trend. I also, because probably you did see Saul speaking at the conference, and today in the morning I just launched randomly 10 talks that he's been giving, and he was always introduced, oh, this is Saul from Jitsi or Saul from 8x8, and if you take a look, it's always his full name, so Rtc.On is not gonna chicken out. So, ladies and gentlemen, Saul Ibarra Korethe and Razvan Purdel.
Thank you. A for effort. Well, it's great to be here again. Couldn't make it last year, but very excited to be here. I brought Razvinator here with single-handedly. And today we want to walk you onto our journey, hey Dan, on AI transcript in Jitsi Meet. A quick show of hands, who is familiar with Jitsi? Yeah, okay, a bunch of hands. I'm going to still do a quick intro because I like to frame how we approach transcriptions. We've heard about transcriptions in a couple of presentations already. And I do think that there is a certain element to the context, not in the AI way of context, but in how we're using them. So Jitsi Meet is a set of open source projects, so it's a pretty comprehensive platform. You can run the individual components of all of them together to create like a full-blown video conferencing platform. We've got APIs and SDKs in case you don't necessarily want to build out the platform. I'd rather integrate with it. And it is an open source community. Jitsi started out over 20 years ago in a sort of different fashion, and it has evolved to what it is today over time. And over this time, we have counted a few notable people using our software over the years. And yeah, we're pretty proud of where we arrived today. One of the latest sort of products we launched as a sort of a next step for Jitsi as well, because many people wanted that, is a platform as a service kind of offering. We call it Jazz, or Jitsi as a service. And it's basically a hosted Jitsi that we run. And all of the features we're going to talk about today apply to a hosted version or a self-hosted version. But there's many customers that don't want to run their own infrastructure. And because we've got APIs at the low level and at the high level, they can build their own video experiences. For instance, one such customer is Brave. So Brave Talk is built on Jitsi, heavily customized, and they run on top of Jazz. We're also going to show how, a little bit, we're going to mention how they integrate also with the transcription side. And CoScreen, for example, have this application to do collaborative screen sharing. So this is using the low-level API, and they've got some client-side pretty cool code that would do this thing with tagging the different windows and stuff, but it is using Jitsi underneath. So now that we know all about Jitsi, let's talk about how we're doing transcriptions at Jitsi. So for us, it all began in 2017. I want to give a shout out to Nick Fassen. He was a PhD student that interned with us, and he worked on adding the first generation of transcriptions to Jitsi Meet. This is his presentation at FOSDEM in 2018, after he had completed the project in 2017. One of my sort of proud accomplishments in life is to be quoted in his PhD. He sent me an email just a few weeks ago. I was very happy to see that he made it till the end, and he still remembered us, so I'm very proud of his accomplishments. The way we did this, it was kind of a showcase of technology. So we showed transcriptions as subtitles in real time. It could do translations because the Google Speech API, which is what we were using at the time, supported that. It wasn't like super accurate, but if you spoke English pretty well, then it did a good job. And we didn't know at the time, but it did sort of set us up for success a bit later down the line in this space. Something that we somewhat coincidentally had from the beginning was separate audio streams. We are going to actually emphasize this further down the talk, but in many instances when you need to do transcriptions, you may find yourself with a mixture of all speakers in a single audio file that may or may not have some challenges. We've got the tracks separated, which at least it means we don't need to, from the beginning, figure out a way to separate each speaker so that we don't get that mix. So our first architecture looked a little bit like this. I'm not going to go into a lot of detail of all the components, but just the Jitsi Meet client would be either the web UI or mobile app. Gcofo is our conference focus, so the one in charge of managing the conference. Internally, Jitsi uses XMPP as signaling, and we use Prosody for that. And Gigazi is our SIP gateway, and that's what became our transcriber. This was a pragmatic decision because Gigazi was a somewhat lightweight client that could join a meeting, receive all the audio tracks, but it also had the media capabilities to transcode, for example, in order to send the call over to the SIP side. Or we could take those tracks and send them to transcribers, for instance, in PCM. And then a key point as well is that the transcriber was an external entity, so we added, in a way, like it was modular, so you could talk to Google or maybe later to something else. So essentially, the client would want to start transcriptions or closed captions, subtitles. We kind of gravitated towards different terminology over time. Gcofo would request that the transcriber joins the meeting. Of course, it would all go through our signaling channel. And once Gigazi joins the meeting, it will start transcribing each participant by sending the audio to the Google Speech API in this first iteration. As the transcriptions came back, they were sent over XMPP chat and broadcast to all participants. Then later on, we would actually, in Gigazi, keep the entire transcript in addition as a kind of a single file that we could store somewhere. And to a large extent, this is the same architecture we have used today, up until we're going to talk about the different evolutions of it. But this was its inception, and it has remained this way for a long time. So maybe by happenstance, maybe because Nick was so smart, or he had smart mentors, we don't know. But we ended up in a good spot that then allowed us to experiment with more things. So we fast forward a few years. In 2020, this architecture remained the same. The feature was still a bit of a gimmick because there wasn't much broad use of it. But some people wanted to give a try to other backends. So for example, we did get, because we had this architecture to plug the backends, then we got contributions from the community, and they added Vosk support. Vosk is this open source transcriptions engine. That's all I can say about it. We haven't actually used it ourselves, but I know some people have, so it must be useful to someone. Anybody here ever used Vosk? Yeah, that. But it's still there, you know, it doesn't cost much to keep around. And that's, you know, it remained like this for a few years because nothing was sort of happening to change the game. That is until 2022, when sort of the AI/LLM, you know, spring or renaissance began. And Razvi's gonna tell you more about it.
Thank you very much, Saul. This sends the slides forward. So hello, my name is Razvan. I joined Jitsi and 8x8 around about 3 years ago, right, Saul? And we already had this transcription set up here, but we were only using it for captions or subtitles. This is useful, I guess, maybe up to a certain point, but then with the LLMs, certain other needs came. And those needs are, I know, yes, live captions, but also do sentiment analysis on a meeting, or, I don't know, do late arrival summaries for the participants who arrive late in the meeting, or extract action points, you name it. So for that, you need accurate transcriptions. And Google at that time wasn't providing those. So, but, you know, by chance, something else came, and that was Whisper. Whisper had a limitation. I'm going to send this back a little bit. Whisper had a limitation. One of the limitations, main ones, I would say, is that it manages to transcribe by default only like full-length audio streams, so audio files. So just give it a file, it will do its magic inside, it will give you back transcription. We managed to override that limitation, kind of, and make it work with live transcriptions. And also because we were a little bit scared at first of sending our data, and I think all companies were at first, at least. Now, apparently, people do not fear this thing anymore as much. People were afraid to send their data over to OpenAI or Google or whatever. So we figured we might run our own LLMs and our own transcribers. So Skynet was born, which basically mashes these two features together. We have Llama on one end and Whisper, live Whisper on the other, in the same project, which is open source, by the way. You can check it out. And it runs as a modulet, so in order to, you can enable like the LLM part or the transcription part. And yeah, we were kind of happy with it. It seemed quite inexpensive at first. You could run inference both with CPU and GPUs. So we started with Llama 2, then we moved to Llama 3. And we also added some tweaks to the entire Whisper thing. I was actually using faster Whisper there, and yeah, that's pretty much it. So this was our first iteration. This is how faster Whisper works. The live Whisper implementation, very broad lines. So from Gigassi, which you already saw before. We established a WebSocket connection to our Skynet with live transcriptions enabled. And we have one WebSocket connection per meeting, so it's not like participant-based. and Gigassi transcodes the opus we get from the bridge, from the SFR, and sends like raw PCM chunks. We have an additional VAD there, which drops silent chunks and takes care of the actual timestamps of the words. This is what we use then to fill out a buffer, transform it into a file, a fake one obviously, send it out for transcription, and then sending the results back. The results are two types of transcriptions. You have like finals, which you can see here, so these do not change anymore. And then you have interim transcriptions, which are in yellow there. At one point, when we know that we have a final transcription, so it's basically a sliding window approach, we send off the final, and we cut that part from the buffer. So we go ahead and transcribe the live stream like this. So this is how the captions used to look like. They work pretty well, but not that well, because these especially because you cannot only show final transcriptions, because the lag would be so they wouldn't be live anymore. They would be like, you'd see them after 1 or 2 seconds, which is definitely too much. So this line of text would jump around a lot, because the more audio you add, obviously, the more context you add, so it autocorrects itself. And it's even worse when you have like 2 or 3 people speaking at the same time. Then it's going to be a mess, and nobody will understand anything. These are a few examples. These are the late arrival summaries. So if you have live transcriptions enabled, say you joined the meeting like 10 minutes late, a private message will be sent to you. Yeah, saying stuff like, Saul has been rambling about how Vim is superior to Emacs. That's debatable, by the way. No comments. So this is the summary you can see in one of the products we use in 8x8, which was built on top of Jitsi. You can see like a call like history thing, where you can see the summary of the conversation, the action items, and the transcript, the full transcript. It's the meeting history. Here you can see the Brave implementation, because we also, so we can handle all this, or we could do the transcription and then communicate to our customers via webhooks each time there's a new final transcription, for example, or an interim one, and they can act on that. So they can then do the summaries and everything else. What else? So yeah, it was all fine, and it worked great. Except with the exception of the Whisper implementation, we also added Oracle in the mix. So now we could do transcriptions with free providers, our own open source Whisper, Oracle, and Google. And it worked. It was cool and all, but it was kind of expensive, because you need to cater to your own GPU pool. Yeah, that's gonna hurt, especially if you need to do it for many, many customers. And here you can see like a few ongoing meetings fighting for GPU time, because we had some limits. We are still using A10s, the GPUs, and for a base with a base model, so only with English only. If you go above like 10 meetings per GPU, then it's not gonna be live anymore. So yeah, you could use also the large turbo model to have like multi-language transcriptions, but you would be even more limited to maybe 5 meetings at the same time. So yeah, it still rocks. It's still a pretty cool project. But then, yeah, you can see the challenges here. When you go at scale, so you have many meetings which need to be transcribed, then it's going to get really, really expensive. The user experience for the subtitles was not great. As I told you, they were jumping around. You cannot really do multi-language because of money, basically. And yeah, we figured out that we actually don't really need real time. Because looking at the stats that we were gathering, we noticed that actually people didn't do it for the subtitles or for the late arrival summaries. They mostly did it to get some insights afterwards from the transcript. So it was a post-meeting thing. So, sorry, I need to hurry up a bit, okay? We decided to make it async or post-meeting. In order to do that, we asked for help from Boris. You already knew him last year if you came here. He created this multi-track recorder, which was initially created for another customer of ours, but we adapted it, which basically takes the audio streams from the SFR directly and encodes all of them into a Matroshka container. And then at the end of the meeting, it will simply upload the recording to a bucket. You can see here, it will upload the recording to a bucket and send a message to a queue. Then the async transcriber will come in, get the recording, extract the various participant streams, do the transcription, and then splice everything back together. I'm going to skip this, but I'm going to go through it real fast. So basically, we have multiple providers you can choose from. You can even do local Whisper or use OCI, AWS, you name it. And it supports like multi-language by default now. It's able to automatically guess the language. You don't need to specify it anymore because you had to specify it with the live transcription. Yeah, that's pretty much it. And this is particularly useful because it's now way cheaper than actually managing the GPU fleet. You can do the transcriptions on CPU only if you really want to, because you don't really care to send it off. Yeah, you can transcribe it also like 15 minutes afterwards. It's not such a big deal for some customers, and it's quite flexible because you can add new transcribers. And we haven't eliminated the real-time transcriptions yet because you can run them in parallel, no problem. But now there's a new chapter, and Saul is going to talk to you about that.
Yes. So you can't seem to rest in this industry. So unless you've been under a rock for the past couple of weeks, OpenAI made their real-time API generally available. And it's mostly used for talking to the AI, but it also supports real-time transcription sessions. What do you know? And the interesting thing is that they had support for a transcriptions API based on Whisper, but the new real-time one, it's priced very competitively. So then, if it's the same price to do it in real time, then, you know, after the fact, then why wouldn't I do it real time? And there's new models like GPT-4o Transcribe. It has a better detection of languages if you're speaking different languages or you switch languages mid-meeting. We've seen cases where that happens. So we decided to give it a try and do serverless, I hate the term, or edge transcriber, if you will, based on Cloudflare workers. So we can even reduce the infrastructure that we've got. The idea is to use a Cloudflare worker or durable worker for rendezvous, where we would receive the one or multiple WebSocket connections with participant audio. It could either be multiplexed in one or separate. There we would create individual transcribing sessions with OpenAI, and this would be the place where we aggregate the transcription and send it somewhere. It sort of looks like this, very professional diagram here. So a key part is also we're tapping directly on the Jitsi video bridge, so we are saving ourselves a bit of infrastructure if we do it this way. We would need to decode Opus there, but there is WASM decoder, so no problem. Or you can ingest PCM directly. That would be better because all you may need to do is upsample to 24 kilohertz and then send it over to OpenAI in this case. And so this is the prototype I've been working on last week. It is working. The jury is out as to whether this might replace our use for the async transcriber in some cases. There are still reasons why you would not want to have OpenAI transcribe your data. We do have some customers that don't want that, so the local option will always, I think it will always exist, but it is really nice that these options now exist, and we're experimenting with them to see whether they augment, replace, or pretty much augment, I think, our existing offering. And trying out Cloud for Workers is pretty exciting because it does help us keep our infrastructure a bit narrower. You know, as you try to do more things as a team, you need to take care of more infrastructure. Doing less of that is pretty nice. And where workers are not being used, they cost you nothing. But you do always need some servers, and scaling GPUs is not cheap. So it is a compelling argument to try and do it this way. So kind of to wrap it up, a few takeaways that I would like to share with you. The first one is that we realized probably too late in the process that subtitles are not great UX for real-time transcriptions. A side panel, however, is. This is our current implementation. You can choose what language you want to see the live transcript on. Here, if you squint, you'll see that the last message is a bit fainter. It's because it's not the final. So the previous ones are final transcripts. When a transcription becomes final, it gets updated on the spot. And, you know, people can go back and scroll, what did he say, things like that, without having to, shit, I missed the subtitle, what happened? So we think this is much better UX, and we spent far too long trying to get subtitles working. So if you're going for it, don't make the same mistake as we did. But if you want to go for it. Pricing is key. So engineering, you know, sometimes we solve problems because we can, but not because we should. So I think in this case, pricing dominates a lot of the decisions that we need to take sometimes. So it's important to keep it in mind as you progress with your engineering. For example, when Razvan said that as we scale out, things became expensive, as an example, we wanted to actually transcribe all the meetings in the company. And for one customer, in 24 hours of a working day, we transcribed 18 days worth of audio. So shit can get expensive, and you really need to look for it. And last, of course, is that the exploration phase does not seem to be over. So, you know, don't settle and stay curious. Thanks, everybody.
Question time. Where is the microphone? Oh, I recognize who rose the hand, so let's start with the lady.
Thank you, nice talk. It's nice to see that this kind of experience is already in the show, you know. So, no, my question is just if you have, as I can see that you have plenty of users in your system, if you have some experience of a difference in the latency or in the real-time experience with depend on the language that you are transcribing.
That's a good question. When you enable, like in the first sort of implementation, right, the Google thing, you needed to specify the language, and then it would give you straight the answer in this mode. In our sort of second iteration, we could do a 2-pass where you would get the transcription and then Google would translate to something. So unless the model can give you the answer straight, which is the case with the newer ones, there was a little bit more latency. But if you think about not using subtitles, right? So in the first iteration, the subtitles were actually in the right language. So while it is possible, the UX is just not good. So when we say a panel, we're talking like a couple seconds of latency. It's just that you would ideally, like if you're watching a movie, you want to see the thing as the lips move, kind of. But that's sort of, it's on the edge of what's possible. And again, it's hard to, I didn't get it, let me go back. So the panel gives you like sub 5 seconds delay. So it's definitely on that ballpark of very usable and not like a huge amount of delay with other languages.
And I think that's why we should prefer calling them captions, not subtitles, because usually subtitles are synced to the people actually talking. And sometimes they even show up before they start talking, so you have enough time to read what's going on.
Exactly.
Yeah, but your users are usually in English language, or you also have other different.
I don't think there's a difference at inference time. You were meaning inference time. There shouldn't be any difference. So if you use English, for example, it depends on the. So for multi-language with Whisper, you would need to use the large model, which is slower because it's huge. But yeah, I think if you would have, like, I don't know, a dedicated French model, for example, you wouldn't see any difference between the.
That's the case we really have with French. Like the French are very French. They want their thing in French, right? So I've been in these meetings where they were speaking French, we were speaking English, and gotta make do.
Yeah, the multilingual have a lot of also of hallucinations with the languages and mixing of that.
It depends. We've worked on removing some of them as well. So there's a lot of work done in the VAD policemen there to remove potential hallucinations.
Yeah, one thing I think we didn't mention is that, like Whisper, so the Whisper OpenAI released, like they kept it, they have released some updates, but there hasn't been like a dramatic update, right? Like Whisper 1 and Whisper 3 are not like GPT 3.5 and GPT 5. The leap is not that big. But the reason why I'm excited about the prospect of using the real-time transcriber is that, well, A, OpenAI seems to have the upper hand on this one, and B, it's on their best interest for the real-time agent model to actually detect languages very well. So if they already need to solve that problem for themselves, like the transcriber would sort of get it for free. So I'm thinking that will, it may still be a problem for a little bit, but it will improve over time.
I think one thing that could be interesting to check, to test, is about the low resource languages. Beyond English, Spanish, that is the second one good in Whisper, French and those, you know, some low resource languages.
Obviously, it's not going to work as well.
No, like about the latency. If the inference of the model takes more time, you know, that the model needs thinking more to figure it out, the transcription for these kind of languages that are less trained in the system, you understand?
I see. The point for us, I think, is a bit that we need to juggle a few balls here, which is that, you know, if you want to have many small models running, that's why I started by saying, this is our frame of reference. We've got this meetings product and we cater for this type of use case. If we need to have a lot of small models and a fleet ready to spin up and down things, like it's a lot of infrastructure that needs to be managed and supported, which means suddenly your effort becomes like pretty expensive in general, versus if you think, well, for these cases, maybe I can self-host, for those other cases, maybe I can offload here. So the idea is to try and mix and match and find what kind of works. And we would also spend more time, depends on, you know, we have a very important customer, we're going to try and figure out a way to make it work. But exploration is not over, as I said. So maybe small models work in your use case, and that's great. And they would work if you deploy your own GC and, you know, run them on Skynet, for example. Like, that's very possible. The way we are looking at things at, you know, scale might result in us running in a slightly different way in some cases. And yeah, we're still figuring out what, I'm not sure if there is one best way to do things. There will probably be a combination of, for this is that, for that is that. Like, maybe small models are good for some languages, and real time will be good for more mainstream ones, I think.
Okay, thank you.
Antonio.
Okay, Antonio.
Nope.
Yeah, it works now. Thank you very much. Like, the presentation was really interesting and inspiring.
Thank you.
Maybe just like to expand really quickly on like the last question. Last year when we were designing our own transcriber, we also had a little study done on the Whisper models. We published a preprint on Archive that's a bit outdated, but we had like some time analysis on the transcription of like some, you know, off-the-shelf datasets. And we had also offline transcriptions for datasets that were not English. And yeah, the time doesn't really change when you target different languages, especially because you can tell Whisper, hey, this is French, for example.
Thanks for that insight. I had missed that you published that.
Well, anyway, yeah, everything is out there. But yeah, like my question, I think it's actually like 3 or 4 questions in one.
Okay.
Like the first one is, so you said that when you want to provide, let's say, live transcription for, let's say, customers that don't want to use third-party services, so they want to have their own Whisper. You do that on every single audio stream that you get. Sorry.
Yes.
So my question is, first of all, have you ever tried doing transcription of like a mixed audio stream? And in that case, have you ever tried, for example, instead of using faster Whisper, I guess you use faster Whisper, using other instances such as WhisperX, for example, that also does a diarization, I believe. So that comes for free alongside the transcription itself. Because, like...
Yeah, so thank you, Antonio, for the question. And by the way, I forgot to mention that also Antonio's solution from yesterday's presentation was kind of similar to what we did. So we can tend to arrive at the same solutions.
Great minds think alike. Huh?
Yeah. And we did test some solutions, and at the time, faster Whisper was the one which performed the best. And also because we do all that sliding window thing, and because we mash all the audio packages from one meeting into a single WebSocket connection, so we do keep a state inside Whisper, and we know that this packet belongs to this user, to this participant, and so on and so forth. So there's really no need to do multiple streams in one kind of thing.
Yeah, because like my point is that if you only have like one stream, ideally you have like one model per meeting instead of one model per participant.
No, actually you have one model for everything.
Okay, so you have
so we only load it at one. So once the pod, the container starts, it will load the model into the GPU's memory, and that's it. It stays there. It's not offloaded. It's not. It will just get used.
So it's one single model for the entire meeting.
For the entire, not for the entire meeting, for the entire instance.
For the entire instance, and then you assume that, let's say, participants would speak one at a time.
So and they don't. When they usually don't, sometimes, but most of the times they kind of wait for one another. So
right. Okay. Yeah.
That's where the VAD and the queues that he explained in the diagram kind of.
It's pretty accurate. Thank you.
All right, I know that there were more questions, but we are approaching the coffee break, so there will be plenty of time to continue this.
We'll be around.
Let's wrap it up with a round of applause.
Yeah, thank you.
Thank you.
Don't forget to scan the QR code, and we'll be back with another segment, 12:05. Thank you.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
All right, I think that once next speaker is done with the football game, we will be able to kick it off. Okay. All right. I think that we are ready to get going. Okay, I think that once I start talking for a little bit longer, people will recognize that the break is over. Or maybe not. We'll see. Okay, then I will be talking. I will do the appropriately long introduction to attract more people, because I would hate them to miss this talk. Our next speaker is Chris Allen. He flew from Boston, Massachusetts to us, and he's a co-founder and CEO of Red5. And a little story that I would like to share is I had a video call with Chris asking him if he will be kind enough to be a guest speaker on our conference. And the answer he gave me was the testimony of a wise man. He told me, "Let me check with my wife," and now he's here. Welcome to the stage.
Thank you. All right, guys, thank you so much. Yeah, so I'm here to talk about what, the biggest buzzword in the industry today, which is AI. And we're talking about how this applies to real-time live video and all the fun things we're doing with this. So first and foremost, why should you listen to me? Well, I've been at this for a very long time. You guys might have heard of Red5 from back in the Flash days. We were the first guys to reverse engineer RTMP. and create an alternative to the Flash communication server back in the day. And actually, the name of our company, Rev5, is all about like it's the call signal for Luke Skywalker. So our vision was we were the Rebel Alliance going against the evil empire, which was Adobe, and blowing up the Death Star, which was the Flash communication server. So that was kind of our roots. Since then, we've been working on all kinds of really cool stuff. We've modernized the Rev5 platform. We're mostly known for WebRTC delivery and streaming at this point. But we're doing a lot of stuff in AI, and so I wanted to talk about that for this presentation. Oh, there's my nice little remote. Yeah, so just a quick bit about our company and our products. So we have Rev5 Pro, which is your self-hosted. It'll auto-scale on top of other cloud providers or on-prem deployments and other things like that. Rev5 Cloud is our fully managed, platform as a service. And then we have SDKs for various platforms that kind of work with both of these. And then this other thing that we have is TrueTime Solutions, and these are like fully baked apps, which we make open source that people can take and mix and match and make their own applications out of them, or use them out of the box if it works for you. So I wanted to talk about LLM or VLMs and detecting things in real-time live video. We're going to go over QUIC system architecture, how we've done it, and our approach to this. Talk about a few real-world applications, and then just talk about where we're going with it. So some of the use cases where this is important. You've got surveillance apps and monitoring. So like we do a lot of stuff with Department of Transportation and traffic monitoring and looking for bad things in the streams. And when you have a video wall of lots of video, it's hard for a human being to be able to monitor each of them and find really small, minute details. And so little AI agents who are watching the streams turn out to be a really good solution for that. In broadcast, I've got this guy flipping people off. That's one scenario. Other things are nudity and other stuff where they want to get rid of that. In a live broadcast, this same technique can be used for that. Other stuff is social, media, user-generated content. You've got bad things happening. They want to blur it out, or they may just want to shut it down immediately. I kind of use the most extreme version. Somebody's doing some violent act in a social media stream. They obviously want to catch that, but others are like nudity and things that they don't want on there. So I'm going to talk a bit about real-time frame extraction and then getting that sent to an AI engine or AI model to actually look at what's happening in it and give you some feedback on it. So this is kind of step-by-step. Create the stream. So we handle lots of different ingest streams with the Rev5 system. So if it's traffic camera or RTSP, we still support RTMP. WebRTC ingest with WIP is still a standard thing too. It doesn't really matter what the stream is coming into the platform. And then that's where our origin node handles the ingest of that. Then we have a thing that we call the Brew API that extracts the image from the live stream, passes that on to an AI process running a visual language model. And then this is kind of an optional step. We can re-encode the video. We can add bounding boxes around the thing that was bad, or the example, somebody flipping somebody off with they can blur out the hand, So this is manipulating the stream coming out. And then obviously the rest of the flow, it can go out of the Rev5 system onto a client who's watching the stream. This is kind of another visualization of the same thing, but this is a very specific one that we're working on for an AI-based ad insertion company. So they want to get real-time frames out of it and then manipulate those and then change the video going out. And so this is using an SRT ingest, going to a Rev5 Pro ingest point. The Brew API is doing its business, handing over to the VLM, and then it goes back out as an SRT stream to their broadcast facilities. So I keep talking about brews. Well, we have this thing called a cauldron. It's like the witch's cauldron, and you can make brews for it. So this was our concept with this. We use this for doing things like transcoding. I know the guys at Stream were talking about streaming, like doing simulcast with WebRTC and having to have the client generate the multiple bit rates from the source. Downside of that, of course, is you've got bandwidth constraints a lot of times, and then you can't always do that. So we take a server-side approach to doing that. We use Cauldron to generate multiple bit rates, and then those can be used to do the shifting up and down with WebRTC streams later. We also have a compositing engine we call the Mixer. I know not the most creative name, but it works. And then the frame extraction is stuff that we're talking about, and writing of new video, which is the encoding part. So decoding and encoding. It's optimized for latency. It's also built for CPU. We haven't really focused as much on GPU, mainly because all the AI engines are eating all of them up, and getting access to these things is crazy and they're expensive. So that was the main reason we did it. And then the Brew is a C++ API that you can use to actually write these very custom things. So first of all, just anticipating that we're going to send a raw frame from a video into the language model, this is what we do to actually configure it. And this is just one use case, which you could take a lot more, but I'm going to show you how we did it for detecting things like fire in a live stream, okay? So basically we say, score on a basis from 0 to 100, and then we've got predefined categories. This actually helps speed up the model so that it's like looking for very specific things. If you have it really broad, then it's much slower, and that doesn't really work great for real time. And then, we're using a prompt basically to do this. And then we are getting the prompt actually to have it return very specifically formatted JSON so that we can parse it and use it later. So here's the prompt. It's kind of crazy, but the main thing is this: 0 to 100, rate how likely things are to occur in this traffic camera. Is there a traffic, emergency vehicle? So we're actually giving them accident, emergency vehicle, like getting fire, etc., road hazard, congestion. Respond in JSON just like the below. So we give them an example JSON file, right, of the format we want. And then the thing just works, which is remarkable. In this case, we're actually using Fast VLM, which is a Apple-made product, and so it's kind of the pre-release, kind of experimental version, and we're actually running that on a server hosted on Oracle Cloud to do this. So the extraction part, this is getting live video coming in and then extracting that and putting it into PNG, into a bitmap format, right? So that then the VLM can read it. So we're currently running a version of this that accepts, H.264 ingest streams. We decode the frames into YUV, which sometimes we can actually skip the other bitmap format, but usually when you're transporting it, you want to compress it a bit, so we use like a PNG to compress it. And that's basically it for that step. And then we send the data to the AI model. When we were looking at this, we had a lot of choices, right? We could upload it to a cloud storage, have it sit there, and then the VLM is looking for new files that are arriving. This works okay, but it does add a lot of latency to the experience because you got that upload speed. We're actually optimizing this, and we're going to provide a service for people that want to run their own language models and want to use an S3 bucket. Or we could implement like an NFS in the cloud and then do a shared file service so that the GPU instance is pulling from that. That would work pretty well. Or the other option is stream it with something like a WebSocket. So we're actually streaming the image data to the VLM, and then it's a push mechanism to the guy instead of it sitting there watching and pulling it. The other option, which I don't think is a very good one, is try to run everything on the same machine. Really powerful GPU instance, runs the media server, runs everything. Well, we opted not to do that. And the one we kind of settled on was the stream the data using a WebSocket to see the VLM instance or the computer that's running that. All right. So the next step is once the AI detects or reads the image, right, that's been extracted from the video, we get a response back in that JSON format that you guys saw before, right? And then we can actually optionally modify the image, right, and then push that back into the encode step on the using the Brew API. Actually, this is probably a little bit out of order. Like, we'd probably send the response first, then grab that and modify the image. So apologies for that. I do notice a mistake in my slide. And then we would also push the metadata, which we have a Kafka-based messaging system with Rev5, where it passes it throughout the cluster. And so every edge node receives that message and can pass it back over to the WebRTC data channel for each of the clients, so that they could, if you wanted to display it client side, whatever the alerts are or everything, you could do that there. All right. And then in code, again, this is kind of an optional process that we can do, but we can take the raw frames. If we have to convert it from PNG again, we'll convert it to YUV, and then our system will actually write that and encode it live. And then it's a modified video going out of the system. I guess hit the volume. There you go. So here's some of the results that we had. So you've got, this is like the frame that we captured from the video. And then the coolest thing about this is you can say, okay, they think there's an emergency vehicle. Maybe there is, I don't know. But pedestrians 100%. Congestion is 90%. So it's saying a large group of pedestrians blocking multiple lanes of highway traffic. It appears to be a protest or a demonstration. You can already see how useful this would be to somebody running like a huge video wall, trying to detect these things. If it gets an alert that describes exactly what's happening, then they can act on it. Right, here's another one. This one I like a lot. Horses are running loose on the highway, potentially creating a traffic hazard, you know? So like, it's very effective. So I'm going to show you a little video of this in action. Let me switch to that. Of course. Okay, so in this example, we've got this. This is pre-recorded because we're running all our tests on this, right? So it was actually one of the biggest challenges was finding good content where it had these kind of incidents in it to be able to run the test. But this one's a particularly good one, as you'll like. I don't know if you, especially the guys in the back seat, probably can't even really tell this is happening, but there's a subtle amount of smoke happening here, and the VLM has already detected something, right? And now it's getting to a point where it's going to get really high, and we skip ahead just to make a video. Like otherwise, it's super boring to watch this for 6 minutes or 35 minutes, right, to see the whole thing unveil. So now it's actually, you know, you see the congestion as smoke is coming up. Now it's giving an alert.
Incident on I-575 North, past I-75, camera 500.
Yeah, so it's using the, you know, the VLM voice. This is like text to voice, you know, technology just to be able to read out what the report is. So we could probably skip ahead just a little bit because I think you guys get the point. I don't want to spend a tremendous time on this.
Camera 500.
But now you can see they definitely know it's fire at this point. And the cool thing to notice here is this is 2 minutes into it, right? Or it's actually, I think it detected that it was certain that it was fire well into this. And that's 2 minutes of a wildfire starting.
Emergency responders on the scene for wildfire on I-575 North.
Right, but if you look at the actual stream, the actual video, it took them 17 minutes for those firefighters to show up, right? Now imagine had this system been in place, they would have been there a lot faster if we could alert them right around 2 minute mark. Or a person who's monitoring the cameras could be like, oh, I actually see something. They may even detect it before the VLM if they're alerted that there's something happening, it can move on. All right. Oh, we're going to move up to slideshow. Yeah, so clearly, this is like using video extraction, and it was kind of the harder part of this, but we can also use this for audio. The Jitsi guys pretty much showed like a very similar workflow, right? Of using audio, ripping audio to wave in this format, which is what you guys were doing as well, and then pass it off to an AI engine to do all of this work. We're about ready to release this as one of our true time solutions. It's a complete meetings app. So it's a bit like the Jitsi Meet. It's like Google Meet. It's, a variety of others like this, right? We've got live transcriptions working in it as well. We're actually using the NVIDIA Parakeet model, which is actually very efficient and can run on CPU, which is pretty interesting, like how fast the thing is. And I was actually talking with Will Law before this presentation. It's like a lot of times you just got to wait for the stuff to come out, right? And that's exactly, I know the Jitsi guys are doing that too. It's like you just sit around and all of a sudden there's more innovations happening and you can apply it. So let's see if we can fire this up. All right, I'm going to join this call. I know Rebecca was going to join it too. Let's see. Oh, whoops. And I think there's probably going to be a little bit of latency on this stuff because of just the internet. Do you want to volunteer? You can be phone.
I'm phone.
So let's see some live transcriptions come out of this. Yeah, so here we are in Poland, in Krakow. Super cool city, and thank you guys for putting on a really great party last night too. As you can see, this is incredibly accurate. I'm obviously speaking really clearly. Maybe you could say something too so we can see another participant.
Yeah, sure. Is it going to show transcriptions on this device also, or is it only on your device?
Oh, yeah, if you click this closed caption button. No, it's hidden under the ... Oh, man, they didn't add it to the UI. Oh, wait, maybe it's here. No, it's totally fine. There's no reason why it won't work here. I think they just didn't add it to the mobile UI yet. So, yeah. But there you go. I mean, this is a pretty efficient transcription. This is running on the lower end model of GPUs running on OCI or Oracle Cloud. And yeah, we've seen really good performance. And we took a very similar approach to the Jitsi guys. I was really happy to see your presentation before this. And like using separate streams, sending to so we could actually isolate which participant is saying what, you know what I mean? Otherwise, it just comes back as a single, like, you don't know who said what. So since we have individual streams, we got Rebecca back there. You could say something. I know you don't want to say anything, but this silent participant. All right. But yeah, this all this code, here, I'm going to hang up. Thank you. I'll take the phone back. All right. So this is going to be, we're releasing this as open source, available on GitHub. You guys can take and mix and match as you see fit. We've also got, I know it's a React components for this, so it's pretty modular and pretty easy to work with. But we're also releasing for Rev5 Cloud the frame extractor, which you can configure to upload to S3, compatible storage as you see fit. The wave extractor as well, so that you can do it either video or audio. We're going to also package some language models with the system to have available. So if people want to use it out of the box, and we've got our WebSocket solution going, you can use that too. And then the idea is also to provide a pretty simple API to configure the VLM to do whatever you want. And And then everything that's on Red 5 Cloud can be used on Red 5 Pro too. So if you want to deploy it yourself, manage it yourself, run it on your own cluster, that's totally fine. And then the true time meetings, we're also going to have that part of Red 5 Cloud, so you can deploy a meeting, customize it a little bit, and then kind of make it your own branding. Or then you can take the code if you want, deploy it yourself, do whatever you want with it, which is also a pretty cool option. So yeah, I think I whipped through this faster than I expected, but it looks like I'm on time. So where does it go from here? Like, I think the key takeaway here is that these language models are changing quickly, and like if you have a concept that you can't quite pull off now, I think the concept's probably valid, and you'll be able to do it pretty soon. I think this is just the trend that's happening with this stuff. And I think, getting language models which are very specifically trained for certain content, like I said, well, one thing that we were doing with our frame extraction model is it has no history, it has no memory, right? If you start adding, hey, remember everything that happened before, so you want to find somebody who's loitering in a scene, then you would need that kind of model. The reason this is so fast is because we're using a single frame. Just analyze what the heck's in that. Don't remember anything else. Just tell me what you see. That's it. I think as these systems get more fine-tuned, we're going to have better power to be able to do things like detect a loiter on a scene or something that's like very concerning that needs the history. The other trend is also running this stuff on mobile phones and locally on edge compute. The power for this stuff is getting better and better. You got WASM to run native code in the browser. You've also got the Onyx, I guess is what they call that, but the Open Neural Network Exchange, which can run VLMs or language models on the devices itself. And then, of course, having open APIs and real-time infrastructure is really critical to make this stuff happen. And in fact, in that, just to give you an example of a WASM kind of AI engine in the meeting app, again, sorry, I should have just kept my same meeting. And again, this is a bug. It thinks I'm entering a credit card for some reason. But let's change out the background. Change virtual effects, I can do this, this kind of stuff, right? And so this is actually doing it client side, right? It's not, I'm not even streaming out to the server right now. Well, actually, I technically am, yeah. But it's doing all of this locally on my machine. It's actually using this, what is it, media pipe, I think? And that's actually what Google Meet uses as well. We did a whole tutorial on this, which is pretty cool. But yeah, I mean, this is an example of like the kind of edge computing happening today. And I think it's just getting crazier and more interesting. So that's it. If you guys want early access to any of the stuff that we're working on right now, please get in contact with me. I'm Chris at red5.net. You can find me on LinkedIn. I really don't use social media anymore, so probably not the best way to find me there. But yeah, that's it. Thank you.
Question time. Saul. Yeah, it's coming.
Thank you, really cool stuff. I remember running into Red 5 as a young Timmy when I was starting, when it was just mostly streaming stuff.
Yeah.
So it's very cool to see you guys still around and kicking some ass. I really liked the video thing and how you guys did the, like putting the confidence level in a graph to sort of show it. This is really nice, rather than not see anything and suddenly, boom, the alarm.
Yeah.
I was wondering, because I missed the first few minutes, unfortunately, if you had mentioned how many frames per second are you running through this thing? Because it can take some time to process, I would assume.
It doesn't in this case. That, like I said, we're using the Apple Fast VLM to do the image detection, and it's wicked fast. So we're actually sending it. I think that test was every 1 second.
every 1 second, so 1 out of 30 frames, let's say.
Yeah. And at 30 FPS video, obviously, it's like, it depends on the video, but we can run it much faster. We just found it, you got to find the sweet spot, right, and not overload the system. But the fact that that language model is able to run on a phone gives you the idea of like the power if you put it on a server, right? It's like crazy what you can do with it.
You're running like on hosted Macs?
Yeah, you can do that, yeah. But it also supports NVIDIA GPU as well. So like, it's like there's a whole research group behind this. It's not just Apple. Like they're kind of making it an open source thing. So.
What was the name again?
A fast VLM.
Okay, I'll check it out. Thank you so much.
Yeah. But I mean, I think the idea is you could apply this to OpenAI. You know, like any of them, you just hand it over, and like I think different use cases probably use different models and be better performance depending on what you're trying to do, right? Yeah.
So yeah, thanks for the presentation. Really nice, really interesting. Just wanted to ask, because I looked into the Parakeet when they first got it out. I don't remember, I think there were some limitations though, regarding the amount of languages it supported.
Yeah. Initially it was English only. Now they've added like 7 different ones, I think. But you have to tell it ahead of time that what the language is you're detecting.
Okay, so it has no auto detection in place, or
not yet, but I think they're going to get to that.
That's really interesting.
But I think it's fast enough, as you saw, like just coming back, that you could probably run a translate from the text and then get it that way. So there's like a couple of hops you could do to make it work today, but I think it's just going to get better and better. Yeah. I was actually kind of disappointed because I couldn't try the Portuguese with our Brazilian team down in, you know, like, but yeah, I think it's getting there. I think this is a classic example of like, it's just wait a little bit, you know?
Yeah.
So.
Okay, thank you.
Yeah.
Any other questions? Okay, I think that will be it. Thank you very much, Chris.
Thank you.
Don't forget to scan the QR code. And during the Q&A session, I saw our next speaker, Rob, just waiting as like a boxer champion, heading into the ring, ready to give his presentation. Actually, Rob was kind enough to tell me a few things about himself that I can more or less comfortably share. So he's been around the internet and real-time stuff for more time than he cares to admit. He also hacked away a lot of things, and he built some companies that yield non-negative returns that allowed him to be free and tinker around things that are of interest to him, which is right now voice AI. Rob, the stage is yours.
Okay, thanks for the intro. I rather set him up, and I was hoping he was going to say something about typing code in a cave in the northwest of England. Okay. Yeah, just to kind of concrete that introduction, my own background kind of starts with the internet, building early internet infrastructure in the 1990s. Voice over IP, I had a UK-based voice over IP company. And conversational AI really since the early 2020s. But most of the things I've been involved in are the idea of building code for infrastructure, because building stuff out is what I do and what I enjoy doing. The talk is going to be in 3 parts, so it really doesn't matter whether you don't know what voice AI is and what the engineering challenges are. If you want to know what the kind of the hard bits and the most recent bits are, and then somehow when I put the talk pricing in, I said I would talk about futures. So if you don't care about voice AI and you just want to know how it might affect you, you know, for things like video streaming, then the last bit. So hopefully everyone should get a little bit out of one of the 3 parts of the talk. So that's by way of an apology for this first bit, which is, you know, kind of voice AI 101. The problem really for voice AI is actually pretty simple, or it is with modern LLMs. It's effectively to take some voice from someone, however it arrives through WebRTC or through SIP, somehow kind of inject the meaning of that into an LLM, because LLMs do all the things and fix all the problems, or create all the problems, depending on perspective. And then when the LLM gives you some output in its kind of native coding, turn that back into voice output and get it back across the network to the guy on the end. I mean, this is voice, right? It's not video. It's not, you know, multi-megabits per stream or anything like that. So what could be hard about this? There are some challenges, you know, particularly if you're using text models, which is all we had to start with. So when I first started playing, I've been doing sort of voice AI using the NLU stuff since, you know, kind of 2020 timeframe. But when GPT first arrived, and kind of a few folks at the start of 23 thought, wouldn't it be kind of interesting if we just take these text mode LLMs and hook them up to voice conversations and they could do useful work for us? And I think what we discovered quite early on is that that's actually quite hard, because there's quite a mismatch between what a text mode LLM expects and what a human being expects from a conversation. So, you know, text chat is delimited. I type something, I hit return. LLM sort of thinks about that. It gives me an inference back, and we kind of go in turns like that. There's no kind of misunderstanding of who's finished and who hasn't or anything like that. And synthesizing a turn-by-turn text chat for an LLM API is surprisingly hard. It's surprisingly hard to detect when I finish the segment of speech. So if we just go on delay, we'll do that wrong. We can do it on a semantic basis, but that's quite hard as well. So there are a number of techniques that we have to use there for voice activity detection. So that's, you know, kind of one hard bit that makes it not quite as easy as that last slide implies. We can bias it by previous utterance length. We've also got the latency implied. So, you know, effectively, where we've got this whole pipeline of voice activity detection going into an STT when we think we've got enough of a sample, and then chuck it at the LLM for some inferencing, get some TTS back, and then send it to the user. That's a multi-second process. That does not feel like a real conversation. That's, you know, it's fine if you know you're talking to an AI and you're willing to walkie-talkie yourself. You know, you say something, you wait for it to come back. You say something, you wait for it to come back. But it's not really great. Same thing for interruptions. You know, there's a problem with AI starts talking and I'm impatient, so I talk over it, or it got the turn detection wrong, so I hadn't finished. And again, you know, there are techniques to fix all these things. So if I get an interruption halfway through, or the LLM gets an interruption halfway through, then I kind of back off. I delete the last conversation turn because I've got control over all this stuff. And from there, we can kind of make the conversation at least give a semblance of being a little bit normal. So it is quite hard, but we do have all these solutions to kind of try and fix the problem. We have one I didn't mention, which is using pipelining for the latency. So we kind of start the output the moment we start getting tokens back. And we also overlap do effectively prospective completions from the LLM. So we've got a bunch of things we can do here. I didn't actually even mention filtering. That's one of the problems, is kind of hallucinations and controlling the LLM output, which in some environments can be kind of really important. But the nice thing about this pipeline approach is we've got these pinch points where we can kind of fix these problems. So we've got a pinch point between the TTS engine where we can do turn unwinding, text filtering, pipelining, and do the voice activity detection. And we've got another pinch point on the output filtering. So, you know, we can... People call these things guardrails. I really kind of hate that term because it's really just filtering, right? So effectively, we can do output filtering there because we've got the text in our hands. So, you know, if it's really important that our AI doesn't, you know, kind of swear at our customers or tell them to do inappropriate things, we can do really, really kind of gross, hacky, kind of algorithmic suppression of words in there. So we've kind of got to a point where, give or take the kind of latency, you've got something there that certainly works in demo land. And we started building around this. Well, first of all, if you go way, way back, based on Asterisk plugins, Dan isn't even in the room, I don't think. Yes, he is. You remember that Asterisk plugin that you did with MQTT to coordinate all of that stuff? So if you go back to sort of 2016 kind of time frame, that was quite a good way of doing things, or it was quite a way of doing things. When I came to revisit this in 2020, Jambones was there. David sort of moved Dractio into a kind of a proper formal project and company, so it seemed to make sense to use that. And it was actually quite good for architecting these pipelines because you could use the gather verb and the say verb. Very, very telephony oriented, because under the hood is 3-switch, so it's very much a kind of telephony oriented solution. Although you can now do WebRTC using a JavaScript SIP engine, but it's not. It's kind of. It's not as pure as a WebRTC solution, but who cares? If your target is telephony, that's not a bad way of doing that. So that was how we started building pipelines, and it certainly worked for some applications. Sorry, my phone notifications are on because I'm going to do something with that in a minute, so I can't actually turn them off. And one of the things that we kind of established quite early on is that actually putting an orchestration layer on over the top of it, where we can specify what all of the things that you need to do to execute an agent right at the top, and then the actual technology you use to implement it is kind of dependent on what you're driving out of the JSON file. So you can see here, this is a particular agent. This is a real agent here. The only bit that is not real is the redaction of my mobile number out of it. But you can see we're kind of specifying here that we're using a model of LiveKit front end, which I'm going to come on to in a second, and then Ultravox, which is a sort of open source speech-to-speech model based on Llama 70 billion. Okay, so that was quite important actually. So, right at the start, we're doing this kind of thing as an orchestration layer, and what it's allowed us to do is every single kind of new technology that's come along, we just drive it from this JSON file, implement it into the underlying layer, and if you want to give a new model kind of a go with your agent, you just kind of run it, change the model string, and off you go. Okay, so come back to this Ultravox thing that we saw in there. So about this time last year, actually, I think I was talking here. And OpenAI had been sort of talking about doing speech-to-speech in their advanced voice, in their app. They had a direct speech model, but no one had released it as an API. So I think Ultravox were the first commercially released speech-to-speech model. If you know different, then feel free to abuse me afterwards, but I think that's the case. And quite quickly, we kind of demoed that, and we just put it underneath that JSON format. And I think I did a demo of it at exactly this event last year, because they'd only released it kind of end of August in kind of trial, so we got on that and had a play with that, which was quite interesting and quite nice. Quickly after that, we backfilled that with Jambones. So using Jambones as a carrier to get a WebSocket into, so you get a number that comes into Jambones. That gives me a WebSocket, so I can use Ultravox's WebSocket interface, so I can use their own WebRTC interface, which actually at that time, and I think still is, was based on LiveKit. And then I can use the WebSocket interface using Jambones. Because if you want to build on open source, like a lot of people, almost universally in the voice AI space, the first release says, yeah, you can do telephony, just go to Twilio, type this in here, and that'll cause a WebSocket to appear over here, and then, hey, we do telephony. That's fine, and Twilio does some quite useful things, which I'll kind of come back to, but I kind of wanted to build it from first principles to understand how to actually make it work. And this is kind of what we ended up with by that point. So, this is the kind of the first third. I'm not going to dwell on this because it's a diagram that I used last year, but basically we've got kind of an orchestration thing, and we've got SIP carriers coming in, and we've got a whole bunch of different workers with Ultravox, LiveKit, LiveKit Real-Time, and Jambones, and then I think about 20 different models sitting out behind it. Gosh, I didn't kill the microphone, that's good. So the only problem with that is that WebRTC is a little bit clunky. So we had WebRTC for Ultravox, but I really wanted a good way of doing WebRTC. So there are a couple of options there, both really good, LiveKit and Pipecat. I know Dan talked about PipeCat yesterday. I've played with them. I think they're great, but I'm allergic to Python in deployment. It gives me headaches and spots. So I prefer to deploy other things other than Python. I mean, you know, for building stuff, it's great. For things like the global interpreter lock and stuff, the performance headaches that I have personally found, and it might be because, you know, I'm not smart enough, but I've found deploying Python at large scale to be problematic. I know the AI guys love it because you can chuck huge arrays around in a time scale where JavaScript would still be garbage collecting something, but hey. So what we ended up with was this kind of scale deployment scenario where we've got a number of provider trunks. The SIP comes into Camma which is configured through our own orchestration layer, so we have lots of numbers across multiple SIP providers. We desperately try and stay out of the media streams, right? Because if I'm buying LiveKit to do this, the full fat LiveKit, now that they've launched their own agent workers, is kind of like about 1.4 cents a minute. If I'm paying them 1.4 cents a minute to deal with my media streams, the last thing I want to do is bring them into a proxy and pay for that bandwidth again on my own platform. So far, we've got away with it, but I think at some point we're going to end up with a back-to-back user agent in there. And then we've got a React-based widget on this side over here that just encapsulates the whole thing. So, you know, React call starts by making a call on our infrastructure, which then nails up a LiveKit room, media to the LiveKit room. SIP call coming in does a very similar thing. Camma is not, it's actually a set of database tables that are built. So that tells the call, and actually there's a missing line there. So there's a SIP line between Camma and LiveKit. That tells LiveKit one instance to go to. So we end up with some quite useful stuff like this. And I pray to the gods of demos for something that I only wrote last night, actually, after the boat. Can we have some audio, please? Super. Can you help me? I'm trying to reach someone in the accounts department. Can you help me? Try again.
Try to help with general queries, but for...
Plug the audio and it works properly. Yeah, I'm chasing an invoice, actually. I don't know if you've got anyone there that can help me with it.
I'm going to go ahead and try to transfer you to someone in accounts who can help with your invoice query. Is that okay with you?
Yeah, go ahead. Really like to speak to them. Thank you. Hi. Oh, I know who they are. Could you tell them we're doing the invoice run on Friday and we'll send them an email? I really don't want to talk to them now.
I've gone back to the caller. They were trying to get help with an invoice. I spoke to the accounts department and they said they're doing an invoice run on Friday and will send you an email then. Is there anything else I can help you with?
Okay, so I mean, you know, that's a bit unfriendly. You wouldn't necessarily architect it like that. But that ability to take a call that's come in as a WebRTC call on a website, do some smart things stuff to gatekeeper it, and then turn it into an audio call if I have to, seems like kind of a cool feature for SMEs, right? I certainly kind of base that on something that I would like. Okay, let's go back to here. No, that was the video that I'm not going to use just in case the demo didn't work. So, I mean, in terms of how we implemented that, it's all done inside a LiveKit room. We provide a set of functions to the agent, so the agent can use those. And if I pop back to here, I can... Yeah, okay, so, I mean, that's kind of what the JSON looks like for this. So we give it a bunch of functions, one to start a transfer, or one to do a blind transfer, one to do a start. No, sorry, in this case, it's only got the three. Start the transfer, finalize, and transfer, reject. So we're kind of leaving it to the LLM to do some stuff there. And in the real world, the prompt would be like 10 times this size, and you would gate it with functions because you would make it check that it was doing the sensible thing before it went off and did it. Okay. I think that's, you know, kind of where we are now in terms of reasonable state of the art with large language model as telephone agents. When I put this talk in, I said, oh, I'll do a bit about the futures. I'll, kind of tell everyone what's going to work. That's incredibly pretentious because my take is that if you want to know what the future is going to be, don't ask a technologist, and I'm just a coder. If you want someone to implement the future, don't ask a politician. But I'm going to kind of do this anyway, so I'm sorry that you're victims of this. I've had quite an interesting couple of weeks. I found this on LinkedIn, and I'm sure Sandro will talk about this a bit later. So there was just this thing where a bunch of people, I think they were all resellers of a particular voice AI company, had all been hit because they put these forms on their website going, check out our AI, type in your phone number here. And lots of people went and typed in all these premium rate phone numbers and called them, and I got done for $600. Oh, I lost 18,000. People made videos about it. A guy made a video saying I lost. He didn't lose 18,000. That's clickbait. But that's there. So one thing that I took away from this is that there are literally the comments on that LinkedIn thread is there are lots of people coming into this space who some of them have very good ideas. And there's a lot of immaturity in the space that we've got to build architectures to actually kind of make safe for these folks. Another kind of observation about futures is the idea of adversarial communication that serves only to generate tokens. And thanks, Tim, for this. I think he found this the other day and posted it somewhere, and I stole it because I thought it was a good one. So this is an example of an AI outbound caller being filtered by an AI. And I'm sure they're both owned by Google, and Google is charging both parties to get rid of that call. That isn't a future that I think is particularly useful and wholesome. So I think some bad stuff will probably happen. I was really glad I came here. Because, listening to Simon Dehaan yesterday about the stuff with WhatsApp for healthcare in Africa, that's the stuff that we should be trying to build. And as a community, if we're architecting stuff for kind of good outcomes and making sure our architectures, kind of mitigate towards those good outcomes, I think that's going to be something where we help rather than hinder society in building some of this stuff. Speech to speech, how much time have I got? Oh no, I'm minus 1.5 minutes. Speech to speech, where's this going? Because there are a whole bunch of people that have invested in pipelines, and they are saying, pipelines are brilliant. If you don't do pipelines, your AI will catch fire and everyone will, it will all be terrible. The ones that really know aren't actually saying that. They're saying speech to speech is the future, but we've got a little way to go in terms of the safety around it. Speech to speech, to me, overwhelmingly is going to be the end solution to this because it's the only technology at the moment that allows us to do that natural voice. And in fact, I can see us getting to a point with it. So speech to speech is where we're tokenizing the audio straight onto the input of the model. We're not turning it into text first, and that allows us to get all the nuance. And yeah, you can do sentiment analysis as a separate out-of-band signal, but that's not the same as understanding the difference between no and no. They're two different words. They mean different things. And a speech-to-speech model will get that. Sentiment may not. So speech-to-speach works, kind of, except where it doesn't. It's certainly got a much better ability to understand the intonation of the audio in. I've got a little story about this, actually. I was building an Ultravox Live Kit plugin, and because I'm a reasonably incompetent coder, I got the audio sampling wrong. I took it from the wrong place. So I think I was feeding a 2400 hertz frames PCM into something that was expecting. It wasn't even a multiple. It was like 4,000 or something, so I was feeding different stats into both ends. And I have a little test agent, which is, it does weather forecasts by doing a couple of function call lookups. So it asks you where you want the weather for. You tell it where you want the weather for. It gets you the lat long, and it tells you what the weather is in that location. It was all working brilliantly, absolutely brilliantly. It would say, where do you want the weather for? I would say London. I would see it doing the function calls. It would give me the answer. The weather in London is 14 degrees. I wasn't getting a transcript out. I've screwed this up, my code is screwed up here. Why am I not getting the transcript? And I went and looked at it, I wasn't getting the Ultravox service delivers a transcript, but they put it through a different transcript engine because they're actually doing, they're doing speech understanding in the directly tokenized onto the Llama model, but people like to see what they've heard. I think they use DeepGram or something similar. And I was convinced there was a problem, maybe their service was, there was a problem with that or whatever, and I went and debugged it. And I went as far as listening to the actual audio, the large language model and the transcription we're hearing. Obviously, what it was a burst. So it wasn't even I was getting the frame wrong, the frame sizes were wrong as well. So there was, we were getting bursts of high-speed voice with a gap and another burst of high-speed voice. It was absolutely unintelligible to me. The AI, the model, understood. I said, London, please. So there's a whole load of risk around that, that we've got these things generating transcripts of what the transcript engine thought it heard. Just imagine an attacker goes and I say I want to transfer $300 out of my bank account, and an attacker just injects a little tiny bit of something that sounds like white noise on the line that says million. So my bank transfers 300 million, and I go back and say, what the hell are you playing at? There's the transcript. Look, I only said $300. That's a fairly gross attack, but I'm sure some stuff like that will happen. But my point is, the understanding of these engines, even with poor quality inputs, is really rather good, except when it isn't. I think it is going to be where things go, and it's in the interest of the model companies, because by bringing the TTS into the model, they can sell you the more expensive audio tokens, and more to the point, they can make you sticky on their platform. So, OpenAI have WebRTC. They've just done a really nice looking SIP actually, but it's inbound only, and you still need all that SVC around it. Ultravox, Gemini 2.5 Pro has got a voice model on it, and Amazon have got Nova Sonic. So, they're all everyone is moving into this space. Did I mention that Anthropic are definitely doing something? So there'll be kind of an Anthropic audio input sometime soon, and I kind of know that externally, so it's not particularly kind of secretive about that. Okay, last thing, and this is the bit where if you're a video person and you're thinking, what's this guy doing at my conference? Why is he taking up so much of my time? I think generative video comes next. So it's quite niche now, but the idea of an avatar talking to you. So, we had me calling an AI there on a WebRTC session on my desktop, and carrying that traffic is no problem at all. But if a decent proportion of all the video traffic on the internet turns out to be point-to-point and individual because it's coming from an AI towards an individual user, forget all the CDNs and all the SFUs and content distribution that we've very carefully put in place over the years. All of a sudden, we found the holy grail. We found the use for edge computing. I never thought there was one, but it turns out there actually is. And what that is putting GPUs out at the edge that we can talk to. I don't think it adds too much value, and people kind of laugh about it, but if you ask Adidas or, Schwartz Crystal or something, if it adds any value, going to the website and having a personalized, very coiffured assistant sell you a pair of expensive trainers or something, yeah, of course it's going to happen. It already kind of is, but scaling it is going to be kind of your next job, video guys, I suspect. So, that's me kind of done. Bunch of links there. PLIs.com is the company that kind of built all this stuff. It is an open source project. It's not a kind of proselytizing open source project. You can find it on GitHub, github.com/applisate. Feel free to kind of take stuff from there. Use the orchestration layer. I like building things like that because I can reuse it myself. Other people can reuse it. If you want to get me on chat, at Matrix.org. RobertApplisate.com is the work address. I've got a personal blog on Pickering.org, and there's a LinkedIn thing over there if you do LinkedIn. I think that's actually absolutely perfect timing.
We have plenty of time for questions. Let's kick it off with Saul.
Well, first, thanks so much, man. I remember our conversations from 2 years ago. You were right on the money. Took me a bit longer to figure it out. So everybody listen to this man. He's usually right. I wanted to ask a question about your kind of two parts. Your thoughts on one of the interesting things with the speech-to-speech is that other than Ultravox, there is just nothing else out there, kind of, I don't think.
OpenAI real time?
Yeah, but I mean on the open source domain.
Yeah, there isn't.
There isn't, and that's...
Well, no, that's not true. There are other smaller projects. It's not fair to say that. But the only people providing it as an open source project that you can go and buy from them as minutes are Ultravox, as far as I know.
Yeah, this was, I tried to keep tabs on the ecosystem a bit, but it definitely seemed like Justin leaving for OpenAI took a hit, and it was a lot slower at, releasing things. I was very happy to see that they finally released 0.6. So question number the first is, do you think that they would survive after real-time going GA and everything that OpenAI is doing? And then I tried the LiveKit SIP thing back when in its very inception, and it was like I couldn't really get it to work properly with a server that spoke honest-to-God SIP. Did it get better over time to where it's more, production ready?
Okay, I'll talk to the first one because that's really easy to put better. I really don't feel comfortable commenting on an individual company and whether they're going to make it or not. People work there, and they're good guys. They're trying to do something useful, and that's kind of a good model. And hopefully they'll either make it or pivot. They've generated some good technology. They could have just been bought by OpenAI, I imagine. Kind of this time last year, and then we wouldn't even be talking about this. So I'm quite pleased they have held out in a way. So that's my take on number one. Number two, sorry, remind me again.
So the LiveKit SIP support,
you
had it in your slide. Like, what has your experience been with it?
Yeah, you can't just, stick a trunk on the end of it. I can't just wire it up to a gamma trunk or something. You can probably wire it up to Twilio or something, because you do have to get the headers just right. And who would want to anyway? Do I really want to expose the domain of my LiveKit room to every hacker on the internet? So you're going to put an SBC in front of it. And yeah, it can be made to work. And of all the options, I quite like it because it is properly, truly open source. I can take all the components of that solution, and if I want to build it rather than buy it from them, I actually can. And Jambones isn't quite like that anymore in some ways.
That's good to know. Thanks, man.
There is over question one over there in the back. Oh, Dan has already in the mic, so let's switch the...
Hello. That leads me on to my question, actually, about protection and SIP and all of that. We've been told for years that SIP, voice is dying. PSTN is dying. We're doing less and less voice minutes, et cetera, et cetera. Feels like that's not the case anymore because of voice AI agents. What's your one bit of advice to anyone that is building a voice AI agent from a telephony historic person? Not that you're old, but but someone that knows telephony.
As an old person, what do you recommend an old person does? Okay. I think actually if you know telephony, you're in quite a good place because you wouldn't have put a number on your website, a box on your website that says, enter a phone number here and I'll call it, right? So I think there are some advantages to being a bit old school telephony in this space because it allows us to, we understand all of the kind of all of the pitfalls that that have existed since before some 20-year-old kid that just discovered OpenAI real time was born, actually, which is scary, isn't it? So I think there are some advantages if you're an experienced telecoms engineer. But then again, you don't know a lot of the AI stuff. And there is this gap between, I've got this old-fashioned UDP trunk that hasn't changed in spec for 20 years over here, and I've got this OpenAI real-time thing here, and it wants to do TLS, and, it needs the headers in a very specific format, and you've just got a massive gulf between those two. So I think learn AI is the advice that I would give them. And, to the folks who are building telco services and don't understand it, learn telco.
But that's really challenging.
We should go out and help them.
We should.
Right?
We should.
Lots of blog posts, lots of videos or whatever.
So I wanted to ask a question about the real-time, like speech-to-speech models and on their pricing, because I tried them out, but the pricing seemed to me like quite blurry on like how audio tokens are counted in and out. And then to me, it seemed quite expensive. And a few months ago, I made a calculation and told a couple of customers that, okay, this is going to cost you like $20 an hour. And then they just said that, okay, a person is actually cheaper than that.
I mean, it is a problem, but there is a spread. So OpenAI at the top end of the spread. Ultravox is down towards the bottom end of the spread if you go and look at it. And some of the newer stuff, Gemini and Nova Sonic, I can't even work out what they're being sold for because I've never managed to be charged for anything. But I think they're quite low, but they're not. Yeah, they need a bit of work to get to the point. So I think it is coming down. And when Simon was saying yesterday, my question to him again was, if you're taking the real-time tokens and you've only got $1 an hour of revenue, how's that working? But I think that is going to get better over time, particularly if you don't need a very capable model. I mean, Ultravox is Llama 70B, and if you do the right tools calls and the right prompting, so you keep everything small and you keep the context tight, you can build some quite creditable agents with that.
I didn't have a follow-up question very, very quickly. So I also noticed that one of the key things is tool calling, right? That's how you add the intelligence to the model. So how do you keep latency down when you have the tool calls, right? Because you need to grab to an external system.
Yeah, I mean, you just explain what you're doing before you do it. How's that any different to a human call center operative where you say, can you tell me what my balance is? And the human says, click, 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 just a minute. Same sort of thing. And you'll notice in that quick demo, the agent said, I'm passing you over. And because that was a prompt I threw up last night after the boat party, it didn't actually do anything useful, like say, hold on a minute, I'm doing that. But that's how you would architect. And a lot of that fine-tuning, the whole customer experience, a lot of it is in that fine-tuning and figure stuff out. And there's a whole load of stuff that I've not talked to on input accuracy. So if you're doing things like taking email addresses and phone numbers direct from LLM input, it generally doesn't go very well. So you need to get some out-of-band metadata if you possibly can.
All right. I think that will be it. Thank you very much, Rob. I'm going to sound like a broken record. Please scan the QR code. And this is the last talk before the lunch break. And it's going to be a reminder that life is not all rainbows and unicorns, AI and whatnot. We're going to talk security. And on stage, we have Sandro Gauci, who is the CEO of the company Enable Security. He prefers to call him Chief Mischief Officer. So let's see what Sandro cooked up for us today.
Right. So I won't be talking about voice AI. I'll be talking about something else. Turn server security, turn protocol security. Why? Well, when we talk about WebRTC security, we often focus on end-to-end encryption. But there is a critical component that is often overlooked, which is the turn server. While it's kind of just a relay, from a hacker's perspective, any public relay is a potential weapon. So I think that makes it interesting from a security perspective. So yeah, first I'll give a bit of background into my personal journey on turn security. Then we'll look at the threat model for turn, and we'll focus on real-world examples. And finally, for those who are running their own turn servers, we'll give some best practices, security best practices. So I'm Sandro Gauci from Enable Security, and we focus on voice over IP and WebRTC security, penetration testing, and security consultancy. So this topic is very much at the core of what we do every day. And I hope that after this talk, you'll have an understanding of the real-world risk of running a turn server what are the ways that you can get compromised, your company can get compromised thanks to that, and then have an idea of what to do about it in terms of fixing these things. All right, so I'm going to start with a screenshot from probably the 90s or early 2000s. So in the 90s, we had lists of SOCs, proxies, SOCs version 4 and maybe 5 eventually, and HTTP proxies where hackers, we call them script kiddies back then, abused, misconfigured public proxies to relay their traffic. And this gave the impression that these hackers could commit crime, essentially, without being discovered by hiding their IP address. Some of these proxies were actually honeypots, but I won't go into that. But the thing is, this same concept of proxy abuse or relay abuse applies directly to turn servers today. So fast forward to 2016, still history in AI terms, for sure. But I'm looking at WebRTC. We had a client who, wanted us to pen test WebRTC platform, and WebRTC, when you look at the protocols, you see, okay, this has great security, but turn is described as a communication relay with user control. And this is very much like those 90s and proxies. It's a bit of a red flag. So when I saw this as a security guy, I'm thinking, wow, this is great because it opens up a lot of possibilities in terms of abuse. And that's what started kind of my love relationship with turn servers. And once we developed, there were no tools to test my assumptions. But once we developed the tools to abuse this kind of became one of the main security concerns and security issues that we kept finding consistently in WebRTC environments. It's not the only one, of course, but it's quite a standard thing. So let's skip to threat modeling. There's the threat modeling manifesto. If you're thinking about anything related to security and you want to assess the security of anything, it's good to look at this website, Threat Modeling Manifesto, and it asks a couple of questions. I'm going to focus on the fun one, which is number 2, what can go wrong? And there's these 3 things that I'm going to go into, because these are the most practical ones and the most realistic security risks you have. So if turn is just a relay, what security does it actually provide? Well, the RFC is clear. Authentication is generally required, but things like encryption and integrity are handled by the WebRTC media itself, so that's not a concern. Turn is responsible for reliable delivery. So clearly, denial of service is a concern there, but but that's it. And the first issue that I wanted to focus on is what we call turn relay abuse. And what do we mean by abuse? In a WebRTC environment, turn servers are meant to relay legitimate media traffic. So by abuse, what I mean is, instead of relaying just legitimate traffic, you're relaying traffic that is not legitimate. And this could be used to bypass firewalls, could be used to anonymize traffic, access internal network resources, and so on and so forth. None of these activities are what the server was designed for. And there's different ways to do that. For UDP, there's 2 main ways to send data to other peers through a turn server. There's UDP send, channel, this channel method. And in TCP, it could also relay TCP as well. So you use TCP connect for that. And they all allow relaying to arbitrary destinations, arbitrary peers. And this flexibility is what enables the scenarios that I'll be discussing next. So the pure address could be anything, including internal addresses, local addresses, 127.0.0.1, and so on, as well as third-party external addresses. The natural solution is to have an access control mechanism. And this is already part of the protocol in Codec, which is the most well-known turn server, most used, and other turn servers as well, because it's by design. But hold on a minute. Well, we said it requires authentication, right, and authorization as well. That's true. WebRTC platforms, however, many of them kind of need to be open to the public so that anyone can register and have a meeting or invite someone, and they maybe join in even anonymously, relatively anonymously, if invited. So the turn credentials, even if you have authentication, those credentials need to be dispensed to anyone. And therefore, the result is that authentication does not really provide any effective protection in many cases. Now, we kept finding this in our penetration tests, but our pen tests are behind non-disclosure agreements, and we kind of got bored of not being able to publish this because it seemed like a big deal. We wanted to boast a bit, I guess. So we looked at the bug bounties, and Slack had a very interesting bug bounty. They allowed us to publish our work. So we decided to go for Slack. And what we did was, this was our methodology, how we abused this issue. First, you get the turn credentials as a legitimate user. You try to make a call, and you see your web browser go and access an API endpoint that gets the turn credentials. Then we pass those credentials to our tool, which starts an HTTP proxy locally or a SOX proxy locally, and then passes all the traffic through the turn server that you have configured and with those credentials. So how did we get from this, which is the temporary credentials that you used to get from Slack, they no longer have this, to something like this, which is, maybe the guys in the back might not be able to see, but this is a metadata service on AWS, on this Slack environment, Slack network, that would give you, for example, a secret access key, which could lead to some problems in terms of security. I have a quick historic demo recorded, where, we're just triggering the call. This is very sped up, so I'm copy and pasting the credentials into a TOML file and a config file that is passed to our tool. I'm not going to call the tool by its name because it's a very commonly used name, but it has nothing to do with the other stunner. And then this starts an HTTP proxy. I'm going to show, okay, first that's my IP of my home IP, 6, 7, 10 years ago. And if I refresh, it's passing through the proxy, which passes through the turn server. So it forwards everything to the turn server. And then you're accessing a local host node export thing. And then eventually the AWS metadata service on 169.254, 169.254. All right. So now they fixed it, of course, ages ago, and they also changed the whole system since then. Anyway, more recently, like a month ago in August, at Black Hat in the US and DEF CON, Adam Crosser published some research. And he showed how to use turn servers for C2 traffic. Now, C2 stands for command and control. It's a set of techniques and infrastructure that attackers use to communicate with and manage compromised systems within a target environment. Target environment, meaning, a corporate environment. You have some, as an attacker, you have compromised some machines inside, but they cannot communicate usually because some security, firewalls, whatever, block that traffic. And what he found out is that one way to get around that is to use turn servers from trusted services like Zoom and MS Teams, which looks like, the compromised machines are making a Zoom call during that short period of time where they communicate. So it's a great talk. You can watch it on YouTube, the DEF.CON talk. And Zoom's solution, I'm not sure how Microsoft fixed it, but Zoom's solution was to prevent peer-to-peer connections, which means, I think, that the turn only relays to and from media servers. That's a solution that might work in some cases. And finally, I wanted to mention that in the last 2-3 years, we've been using or abusing turn servers during our penetration tests as a trusted IP. And I'll explain it with some quick videos. So here we have SIP. You might have a CPaaS network, and it has both a SIP trunk and a turn server on the same network. And the attacker wants to make calls through a corporate PBX, for example. And the corporate PBX has IP whitelisting or IP authentication, which is not really authentication, in my opinion. But they are unable to from their IP, of course. It's not whitelisted. However, if the attacker were to somehow, be able to use the turn server, they could pass that traffic through the turn server, and if the IP or IP range, in many cases, is whitelisted, then they could make calls through the corporate PBX and possibly commit fraud, toll fraud, which could be hugely problematic. And we've been finding this. We need to publish a proper blog post about this, at least. But yeah, it's an interesting way to abuse turn relays. All right. Next topic is denial of service. Now, like any public service, turn servers could have denial of service risks, from resource exhaustion to bandwidth saturation, which is very hard to protect against. But there's also another unique threat where your turn server might become part of a participant in attacks against others that have nothing to do with your WebRTC environment or with your turn server, which is becoming part of an amplification attack. Now, when thinking about denial of service against your turn server, it's important to understand the scope, right? And to understand how much of your traffic is passing through a turn server. That's kind of your attack surface. So, don't forget your media servers, which are probably receiving 100% of your traffic. If you're thinking about this problem, start from there. But yeah, let's talk about reflection attacks, because attackers are actually abusing this in the wild. And the way it works is the attackers spoof the source IP address. And this is in general for amplification attacks. And they spoof the source IP address, the target server, it might be DNS, NTP, or even turn, in this case, that's what we're talking about, receives that request on UDP and sends a reply. And the reply goes to the spoofed IP address, which is actually the victim, right? And when they do this on scale, they get an amplification factor. Now, the amplification factor of DNS is you send a small packet and the response is like 50 to 70 times more. NTP also, but turn is just, the maximum is just 4 times. So whenever we looked at it in the past years, we're not interested in this personally as pen testers. But yeah, it's being abused, and these are two main ways to abuse it. And the thing is, in June, the core developer, Gustavo Garcia, for Codec issued a blog post, and they did a major, a release which fixed or changed some of the behaviors of Codec, disabled some things, and so on and so forth, so that the amplification factor goes down, and so that there's less abuse. And same with the Stunner turn server as well. The developers were also trying to shrink the response so that it no longer has an amplification factor. It could still be a problem, but it's better. The third issue that we want to talk about is software vulnerabilities, which affect, any software really. So turn servers are software too. Software has bugs, and vulnerabilities, so that hopefully get fixed. But yeah, Codec, of course, has quite a history of security issues along the years. It's the oldest one. It's in a certain language that has a lot of potential for vulnerabilities. So yeah, the whole point is keep your servers patched to the latest version. Now we've seen how turn servers can be abused for relays, denial of service, and of course can have vulnerabilities, so they can lead to compromise. Let's bring it all together and walk through a security checklist to protect your systems if you decide to have to host your own turn servers. So firstly, I think it's important to isolate the turn server to its own network or security group, so that if someone uses the relay to reach other systems, they can only reach the turn server itself, at most. And access control rules, of course. You could also possibly, not always, of course, but you could also possibly allow traffic to just your media servers. Could be an effective approach. I'm sure that not only Zoom do this. We have found this in other places, I think. And then you do protocol hardening. You disable things that are no longer maybe necessary or not necessary for your needs in particular. You could disable UDP listening, actually, because amplification attacks rely on UDP. You could sometimes. On the other hand, you could disable TCP peer relaying. So on the other side, which would protect against what I was doing with Slack, which is relaying HTTP requests, which require TCP and not UDP peer. And rate limiting, it's useful in any software, any server software. It could help you prevent denial of service. You could sometimes protect the credentials. Before I said that you often need to dispense, temporary credentials to anyone, but that's not necessarily the case. There are cases where you have a turn server only for one organization, so you don't have to have no authentication on your turn credentials API endpoint. You could have authentication there and keep them up to date, like I said before, and monitor traffic and servers for incidents and attacks. Of course, that if you log too much, you could introduce denial of service. So it's, watch out how you do that, but I think it's important to be able to trace back attacks. Concluding, so I would like to thank Alfred, my colleague, who built the tools and did a lot of the work behind this presentation, and the people at Software Mention for this conference. It's been really a great event, and our customers, because they give us very interesting work to do, penetration tests, and anyone who's contributing to RTC security. There's not many, but some of them are in this room, so thank you very much. Key takeaways. Their servers are powerful proxies in a way. Don't just think of them as a simple media relay. they can relay more than just that. They can become weapons against other systems, so keep that in mind. It seems to be a real problem, actually. And so the solutions involve mainly three things, I would guess. Isolation, restriction, and keeping them up to date. What to do? One thing is to stay informed. We publish a newsletter every month on WebRTC and voice over IP security. So that's one way. And another way is, of course, if you don't test your solutions, your real-time solutions, then you don't know what security issues you have until maybe it's too late. So test, and test. This is how you get in touch. And if you want to scan our QR code for the newsletter, that's the newsletter subscription page. Thank you.
Anyone has more curiosity about security stuff? Chris, in the back.
Are we live? Yes. Great talk, Sandra. Thanks for sharing the details of how you can exploit turn servers. But you mentioned the bug bounty program that Slack had, and you used that to actually kind of fund the efforts. This is kind of maybe a philosophical question, but do you think these things are effective, especially when you've got like players like Meta who did like the Facebook pixel of like contacting a local server on the phone, which is actually running WebRTC, and like, is it the what is the wolf guarding the hen house kind of situation? I'm just curious what your thoughts are on this.
Yeah, I mean, we didn't really fund the effort through. I mean, we got like 3K or something like that. It's for us, bug bounties are not worth it from a monetary point of view. Okay, so whenever we did bug bounties, it was more whenever we could publish, essentially, or at least get in touch with the vendors when we don't have contact already with them, if they're not our clients, essentially. Now, the topic of bug bounties, how effective they are, there's pros and cons. You get when you start a bug bounty, as a vendor, you get a lot of feedback from possibly AI-generated reports and so on nowadays. So yeah, it's a long topic. I think we can talk about this during the lunch break.
Any other questions? Gentleman here in the front.
Thank you for the presentation, it's amazing. But I have a question. What kind of security controls do you actually suggest to at least mitigate some of the problems with RTC or turn servers?
Yeah, I mean, one would probably follow the last 4 or 5 slides.
I checked the authorization authentication, but how do you actually put it behind a WAF? Would you compromise the performance by using VPN or IPsec? Would you compromise?
It depends on the case, right? But web application firewalls don't understand stun or turn. So no, that's not the solution. That's why I didn't even mention any WAF or firewall or anything like that here. I mentioned turn software-specific solutions because, that's, in my opinion, now people differ, but in my opinion, that's where you have the problems, and that's where you should be fixing. That's my personal opinion. And also, the firewalls or web application firewalls don't really understand these protocols.
Okay. Dan in the back. And I did hear that there is a chat question. Let me see.
Have you ever gone after one of the turn platforms such as Cloudflare or Twilio? Or can you not talk about it?
Not yet.
All right. Also, guests at the chat, they asked, does adopting an SFU architecture remove the need for 10 relays for NAT firewall traversal and eliminate the security concerns associated with peer-to-peer WebRTC mesh deployments? If not, what risks remain and what best practices should be applied?
I think I need to read this one. SFUs, I've seen plenty of cases where turn is not necessary, it seems. If SFUs are, solving that problem, creating others, I suppose. But yeah, we've seen some cases where peer-to-peer WebRTC is used, but most cases, we haven't, seen it used that much. So yeah, What was the second question?
Very good question. I guess it was one long one, and I guess that the answer has been already given. So let's wrap it up with a round of applause for Sandro.
Thank you.
So we reached the point where there is a lunch break. You know the drill. Lunch is second floor. We will be back around 3 p.m. for the last segment for the day. Also, if you'd like to have some fun during the lunch break over there, Software Mention crew build up a little game based on our tools. So feel free to play with it. Thank you.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.
Does it work? Okay, it works. Bittersweet news. We are starting the last session of the third edition of Rtc.On conference. And on stage, we have Jakub Chmura, who works here at Software Mansion. He's also known as JC. And over the past 2 years, he managed to work on, I think that the most exciting projects that I've seen here. One of them was related to real-time video and removing objects real-time. And the other one is something that I personally do believe as a bet for the future, meaning the AI inference directly on edge devices. And this is the topic of Kuba's talk. Kuba, the floor is yours.
So, hi everyone. My name is Jakub Chmura, as I was introduced, and I'm a software engineer at Software Mansion, where I work in our in-house AI team. And today I wanted to talk to you about what we think the future of AI is going to look like, and why it might not be distributed the way you think it is. So, about 3 years ago, ChatGPT went viral and changed everything. Suddenly, everyone was generating code, talking to AI, transcribing meetings, and it all felt pretty magical. But under the hood, almost all of these services operate in the same way. So you send a request to the GPU cluster that costs more than my house, and a few seconds later, you get your response back. And we all use this daily, but unfortunately, it does have a couple of big drawbacks. So let's start with cost. While consumer-grade subscriptions like ChatGPT Plus seem affordable at $20 a month, the reality behind the scenes is pretty different. So to host like large models, you need dozens of high-end GPUs, which does not account for model training and maintenance, which is also a very big cost. You know, you have to pay for electricity to maintain the GPUs. You have to provide scaling for your users. And these costs inevitably have to get passed down to users. So privacy is another major concern. Every API call potentially exposes your data to third parties, and there's often unclear language on how your data is used for further model training. So for businesses handling sensitive information, this creates some compliance issues. Your data also gets stored in some third-party company database, which increases the chances of your data getting leaked. Then there's scaling. You probably know how hard it is to scale video infrastructure, so you can imagine adding a ton of GPU computations on top of that. And during peak usage, your users are competing over the same resources, which can lead to rate limiting and potentially degraded performance. There's the connectivity requirement. So no internet means no AI, which can be problematic for some use cases or applications, mobile applications or users with poor internet connectivity. Then there's latency. So using cloud AI obviously requires you to transfer data over network, which you probably know can get complex and introduces some latency. So what is the solution? We believe you have it in your pocket, and it's your phone. Each and every one of us carries around a pretty powerful compute engine in the pocket. So maybe we can use that compute engine to power AI models. In this talk, I'll show you what is possible today and briefly describe how it works under the hood. But before I do, let me introduce you to how we even got to this point. One of our first projects was about disappearing objects from video streams in real time. You can think of it like a real-time invisibility cloak for anything you don't want in your stream. In our case, that was bottles. We spent quite a bit of time trying to get the best model architecture so it fits within what we considered a real-time constraint. And we finished with a pipeline that could localize an object, erase it with visually plausible content, and then stream the resulting frame back to the user. All of this functioned at close to 30 FPS on a consumer-grade GPU, NVIDIA GPU. The problem with that was that we could only maintain up to 3 connections at a certain point on a single GPU. Here's a demo of how that looked like. You can see the bottle is not there, and it's sort of erased with what would have been there if not the bottle. Once we were done with online inpainting, we wanted to see how we can employ a similar strategy for offline deployment. So processing full video streams would be too computationally expensive to do on a phone, so we decided to tackle a different problem. We wanted to create a photo editor app that would erase objects from images using a reference image. So that would hopefully help the model, make it much easier for the model to sort of know what to fill in the missing area. So given our previous experiences with similar problem, we optimized the architecture. We had to deploy it on mobile somehow. So we were searching for the right tool for the job. After extensive research, we found out Executorch, which turned out to be our favorite tool right now. And we successfully deployed it. And all of those experiences led us to a point where we are pretty excited about on-device AI, and we started digging deeper. Cool, so now let me introduce you to some tools that might help you build stuff as a multimedia developer. So there's a lot of open source frameworks for web, mobile, or other platforms that let you run AI locally. If you're doing transcriptions, which I suppose many of you are, then I'm pretty sure you're using some third-party service or hosting your own backend, which you send audio to. What you can actually do instead is try running it directly in the browser. For example, a very popular model, which has been mentioned today a couple of times, Whisper, can be easily run with the help of a tool called Transformers.js on a web GPU. And before you think it's slow, here's a demo of it running on my MacBook. Unfortunately, you cannot hear it.
Speech in real time without sending any data to external servers.
Okay, so hopefully you can see the latency is pretty small. It's capable of processing at around 80 tokens per second, which is pretty fast. If for some reason you don't want to do this locally, what you can do instead is try running voice activity detection locally, which is usually more lightweight, and only stream relevant audio chunks to your backend. This way you possibly reduce redundant calculations or reduce hallucinations. On that note, since speech-to-speech has been mentioned before, there's a very cool model called Hibiki that lets you do speech-to-speech translation on a mobile phone. It is very small, and I recommend checking that out. Then there's computer vision. So I'm pretty sure a lot of you are familiar with the famous feature from Google Meet that blurs your background. This has already been said by Chris, but Google is pretty open about this, and we know that this works entirely on device. The underlying model here is responsible for detecting the background, and then everything that's classified as background is blurred, or some specific picture is applied to that area. The fact that on-device AI is a part of one of the biggest products out there shows that it's no longer fairy tales, but it actually reaches millions of users. Here's how it works. The video texture is taken from your browser, and it is passed to a MediaPipe WebAssembly pipeline. So the pipeline is responsible for doing machine learning inference and refining the segmentation mask. So a common practice in computer vision is to downsample the image before passing it to the machine learning model which greatly reduces the number of computations. So the actual model can run faster. After the inference, you just upsample the output. In case of segmentation, you also need to refine the output mask because it has rough edges after the upsampling operation. And below you can see a performance chart. As you can see, it's running at 70 FPS, the entire pipeline, on a MacBook Pro 18, which is Intel-based, so not that new. And they also have smaller versions of that model for lower-end devices. Also, this feature is actually coming to the Media Stream Track API, which is cool. But it's not just about transcriptions anymore. Recently, VLMs have been on the rise, and vision language models are able to understand both text and image data. So, for example, if you show them your camera feed, they should have a basic understanding of what is going on within each frame. So Apple has recently released a model called FastVLM. It contains just 500 million parameters, which makes it small enough to run in your browser or on your phone. You can see a quick demo of it. As you can see, it is able to do OCR or count fingers. This shows that as research progresses, small models are becoming more capable, and you can see on the screen that it's pretty good. You can also run standard LLMs too, like Llama 3.2 or Qwen 3. They're all already achievable. Big tech companies are investing a lot of resources into frameworks and adoption around on-device AI. And Google has recently launched a set of APIs available natively within Chrome that let you do some pretty cool stuff. So for example, you can translate text from source language to target language. You can summarize blocks of text, or you can ask it to write something. So you get everything built in within the browser. You no longer need to compile anything to WebAssembly yourself and have all the headaches. This is made possible by introducing multiple expert models and Gemini Nano under the hood, but this is currently under a feature flag. This is not just a software shift. It requires changes to the bare metal, and Apple has integrated neural processing units since 2017, which is a specialized hardware for AI tasks. Their performance is measured in TOPS, which is trillions of operations per second. This chart shows how TOPS have grown with each flagship chip, and the steady rise shows that, if this trend continues, that devices in our pockets will become even more capable than they are now. So another example of big things in the space is obviously Apple Intelligence. Apple has already integrated multiple on-device AI models directly into iOS and macOS. So, for instance, we have the object segmentation model, which lets you take an object from a photo by tapping on it and localize it on a per pixel level, so you can see it on the screen. A very notable feature is also grammar correction. You obviously don't want your private chats to be sent over to third parties, so this is very nice that they're doing this locally. This is honestly my favorite, semantic gallery search, which allows you to look through your image gallery by using natural language. So you don't have to scroll through thousands of pictures if you're looking for something. This is made possible by models such as Clip or Apple's Mobile Clip. The new AirPods Pro also feature a live translation feature during a phone call, which is all computed on device. What is very exciting as well is that Apple has made it possible to use those models by providing native SDKs. This means that you can use AI that's built in your system within minutes with no headaches. So there are some things you need to consider before you use any of these tools. Obviously, since you're running it on a client's device, there's a limited computational power. So therefore, you can't run models as smart as the ones you can run in the cloud. You usually have to make a trade-off between performance and the quality of the model. And if you're continuously using large language models or other large models, then you also have problems with high power consumption. If you want to release another version of the model, this might be problematic as well, since it usually requires the user to download the model all over again. There's also pretty high development complexity compared to what you get in Python or other languages with mature machine learning ecosystem. Lastly, the performance is dependent on the device that it's running on, meaning that some users may experience poor experience while other not as much. So I mentioned executors before. Now let me give you a little introduction to the tool and how it works under the hood. So Executorch is an open source toolkit for that's developed by Meta for enabling on-device AI machine learning features across edge devices, such as microcontrollers, mobile phones, wearables, whatever. What is exciting about Executorch is that it offers hardware acceleration, meaning that at runtime you're actually calling the native implementations for machine learning operations. It is also PyTorch native, meaning that if you train your models in PyTorch, you never have to leave to ecosystem from training to production, which is very beneficial because the third-party export tools sometimes are not as reliable as we would want them to be. It is also highly customizable. You can even control how memory is allocated before the actual runtime. So what needs to happen for your model so you can run it on an edge device? So the entire process consists of two major steps, ahead of time and inference time. And ahead of time, you can think of it as compile time. It all happens in Python. And the inference time is basically runtime, and it happens in C++. One of the main design choices of Executorch is to offload as much work as possible outside runtime, so you don't have to do this at runtime, effectively saving precious seconds. The AOT part produces a high-performance flat buffer binary containing Executorch instructions, which are then executed by the runtime on the client's device. So here's the runtime part. The exported program is deserialized and loaded into the runtime. It contains symbolic operator names, such as add, multiply, and so on. And the runtime maps these symbols to actual C++ functions through the operator and backend registry. So you have to link specific backends and kernel libraries against the runtime, depending on what platform you're targeting. Then it sequentially executes instructions. And what makes this run everywhere, from iOS to bare metal, is the platform abstraction layer at the bottom. So it abstracts away all of the system calls for memory, logging, and timing. This way, the runtime can function even when there's no system to call to. Now let's see the code that is needed to export your model. So the AOT part starts with a PyTorch model. I'm using here a very simple example with a single linear layer, but this could be your audio classifier or whatever you need, basically. Once you have the model, you need to pass it through a process called torch export. So torch export takes your neural network and breaks it down into basic building blocks, such as addition, matrix multiplication, convolutions, and these operators form a computational graph that represents how data flows through your model. Once we have the exported model, this is where most of the mobile optimizations kick in. So one example of performance optimization is quantization. Usually the weights and activations of the model are stored using 32-bit floats, which can be reduced to lower precision, trading off some quality. The most important part here is the delegation part. This means that you train your models in PyTorch, but at deployment, you can actually call Apple's or Qualcomm hardware-accelerated operations. So the takeaway is that you get native performance without learning 5 different frameworks. And if a backend doesn't support a certain operator, it falls back to CPU. So in this code snippet, you see we're taking out the torch exported models, and the XNNPAC partitioner is basically responsible for choosing the parts of the graph which can be delegated to XNNPAC. And finally, we're just saving it to a file. And where do we fit in this ecosystem? So for the past year, we've been working on React Native Executorch. Executorch itself is a great tool, but it does require some setup, especially if you're coming from a React Native background. First of all, you have to set up and link all the needed libraries. You need to export your models. You need to make sure that your pre- and post-processing are rock solid. This is time-consuming and requires deep experience with native code and machine learning internals. We want to abstract this away by providing a set of JavaScript APIs that just work, and you can set it up within minutes instead of weeks. Here's a list of features that are currently supported. One of the most notable ones are, of course, LLMs, amongst which we support Llama, Qwen. We have tool calling, Whisper, text embeddings, OCR, and many more. But we're actually aiming to go beyond this, and we want to create an entire ecosystem for on-device AI experiences. So we have already created a small extensible library called React Native RAG, which lets you enhance your LLM's knowledge with external documents. completely offline. This means that you can upload some third-party documents to your LLM as a context, and you're not sharing your data with anyone. So here's all the code you need to get started. And to install, you just npm install. As you can see, we're doing a bunch of importing. Then we're basically calling the useLLM hook. And we're defining the handle generate function, which defines a chat variable, which is an array of objects basically representing a chat turn. Lastly, we're just calling the generate function, and that's it. If you've used the chat completions API by OpenAI, then this might seem familiar to you. We were heavily inspired. Whether you are a React Native developer or not, we got something cool for you. We created an application called Private Mind that demonstrates what is possible today with local workflows and released it to the App Store and Google Play. So I highly encourage you to check it out and play with it. So let's do a demo of the RAG feature. So I have a chat here with Quen3 1.7b quantized. And I'm going to pass it a PDF file, which is basically the Rtc.On website. So I can select that. And let's ask it, what is the executor's workshop going to be about? And before I do that, let me turn on airplane mode. OK. So it needs some time to think. OK. Once it gets started, it's OK. That's actually pretty true. I don't know which one of you was on the workshops, but it looks right to me. And when is the conference happening? Yeah, that seems about right. And yeah, this is all open source, by the way. You can check it out on GitHub. And on-device AI is not perfect for everything yet, but small models are getting more smart, and hardware is getting faster. And new doors open daily. So it's up to you if you want to use it today, but you should definitely keep an eye out on what's happening in the space. Thank you.
Thank you, Jakub. Are there any questions about this fascinating stuff? One question over there, gentleman in the back.
Quick question. Did you try to convert PyTorch models to native CoreML models and use it within native environment?
We haven't directly converted PyTorch to the CoreML models, no, but actually Executors does offer a CoreML backend. So effectively, with Executors, you can call CoreML's native stuff. So yeah, hope that answers your question.
Yeah, thanks.
Any other questions?
Great talk, man. Thank you. I think this is more of a comment rather than a question, but I think the cool thing about all the stuff that runs on local devices, particularly on phones, it can actually be applied to server implementations to make it actually cost effective, which I think that's where the future is going. But yeah, highly distributed, whether it's on client or not, is definitely the direction.
That's true. Thank you.
Unless there are any other questions, let's wrap it up with a round of applause for Jakub. And we are welcoming to the stage Niklas Enbom. And today he will be talking about AI and his company that he co-founded, and he's head of R&D called Gigaverse. That strikes my nerd chord very well. Pretty cool name. But previously, he's the one, if you have a trouble with WebRTC, he's the one to blame because he is originally the person who was on WebRTC team. He was bringing this technology to Chrome. So, yeah, Niklas, welcome to the stage.
Thank you very much. This is my first time here, actually my first time in Poland, and this conference is actually a great coincidence for me, because not only have I been in the real-time communication space for 100 years, we also have most of our development team for Gigaverse here in Poland, so we actually just spent 3 days together in Wrocław doing a hackathon, everybody together for the first time. In addition to that, we are also building our mobile clients using React Native, so we're using a bunch of the libraries that's developed in this building here by Software Mention. Anyway, today I'm going to talk about building real-time AI features into your audio and video platform. But I have to start with describing what Gigaverse actually does. We believe that now, more than ever, the world needs a new media format, one that enables real-time discussion and amplifies every voice. This new format has to be live and interactive, fostering dynamic conversations. It has to be community-driven, built by and for the people, and it has to be free from platform interference, especially when it comes to monetization. We are a live video platform where creators and communities can engage, retain, and monetize their members. Here's a couple of example use cases for our platforms. We have music artists that use it to connect with their fans, allowing them to ask questions in person and getting a much more closer connection than they can using traditional social media. We enable podcasters to go live and let listeners contribute to their show. At the same time, they retain all the assets from the show so they can edit the session and produce a normal podcast from it. We have smaller communities that use this for live online discussions. This can be anything from discussing news and politics to online coaching and support groups. We also have some organic usage in the education sector. That's individuals that teach online. Some of them are freelancing, some of them are affiliated with universities and other organizations. However, going live to a large audience can be hard. Many times it requires a lot of preparation and several people to run it. Someone might be working on see what's happening in the chat, one person might be busy doing moderation, and someone else is trying to engage the audience. This leads to that often live events are either rare and expensive events, or they become mainly a one-to-many experience where a single creator is streaming from their cell phone or their laptop. At Gigaverse, we are leveraging AI to help solve this problem and make them easier. So I'm going to run a quick product demo to let you know what it's all about. I'm going to need audio for that.
Gigaverse. My name is Yashvi, and I am on stage as the host of this live. The rest of our team is here in the audience. You can see them in the front row on the top right with their videos on. The live chat is blowing up, as you can see, much like many other live platforms. We have an Insights tab that is an AI-powered dashboard and highlights the most important moments from the chat so that you don't miss anything important. These could be good comments or good questions like this one. The 2 buttons that come along with it allow me to feature and give a nod to someone in the audience, or I can do one better and bring them up on stage.
Yashvi, how's it going?
Hi.
What's the interactivity all about?
That's a good question. I'm glad you asked. Live interaction leads to higher engagement in communities. Let's fact check this. So what you'll see is our instant fact checking feature. The statement pops up at the bottom. You see that loading icon where it scours the internet for sources to support or disprove this information, and you see the answer pop up below. Spot on. The links that you see click out to the sources, so you always know where you're getting your information from. But this is one of our most exciting features. Once you're done having a question like this come on, we have basic moderation tools built in as well, of course, where I can now remove Avi from the stage and send him back into the audience. One of our other AI-powered voice-activated features is polling. I can say something like, have you ever wanted to interact face-to-face with a creator in a live? Let's create a poll. And the poll will pop up immediately, you'll notice, with the options filled in as well. The Gigaverse magic doesn't end with the live itself. If I record this live, once it ends, our AI will deliver instantly generated post-live assets. These are edited and captioned highlight clips, audio stems, transcripts, everything that you need to upkeep your social media presence and keep your community engaged in this multi-platform landscape. Our community page also has a chat box, a schedule, everything you need to keep the connection going between live sessions as well. The stage is open for the rest of our team to come on and say hi.
All right, let's move on. As you can see, I'm not brave enough, as some of you, to actually run a live demo of this, so that's I'm using a recording. So yeah, go through the sort of AI-powered features we have. Insights tab is essentially the control panel for the creator. It shows you, a highlight overview of which topics are being discussed in the chat. It also highlights, impactful messages and questions that are relevant to what you are talking about. It's also the shortcut for the creator to invite people, display questions, things like that. We support real-time polls, so all you have to say is, you say a question, you give some sort of hint of what the answer should be. You don't have to spell them out in any way, and say, let's create a poll, and it will appear. Then we support fact check and sort of added information. We don't really like the word fact check because the purpose is not to prove some right or wrong. It's to help, give the viewer more context of what's being discussed. This can be very useful if, if people are talking about a company or a person you haven't talked about, you haven't heard about. This is something that happens automatically, and it can also happen by a voice trigger. Then we have auto moderation, both on chat, and we can also moderate the video before someone joins you live, so you can check that a person is not nude, they're not holding a gun, things like that. And the major benefit from doing AI-based moderation is that you support sort of free text configurations. You can say that, hey, I don't want to have any questions about the weather in Poland, let's just talk about the soccer games, and all those questions will be automatically suppressed for you. So this was a high-level intro to our platform and product. In the rest of the talk, I'm going to focus more on the AI features, and especially AI features that happen in real time, because I think that's what this conference is about. So let's give sort of just a quick overview what sort of the data we have to play with. For every audio track, we transcribe that into text, so it's easier to process. The chat is obviously text to begin with, so we just have to forward that to our AI services. From the video tracks, we collect images, but also short video snippets we can use for analysis. And then, of course, we have all the information that lives on our backend, the session description, what persons have written about themselves in the user profile. And then for every event, we have whatever moderation guidelines someone has set for the session. So this is a very, very simple, overview of what sort of most video conferencing solution looks like. In the core, we have the client that sends audio and video back and forth through the SFU. Very often, there is a chat service too. The chat service might be more or less integrated in the media path. But many times, it's sort of a separate service because chat is something that lives, could live all the time versus the real-time session that starts and stops. And then we have all the other backend features like authentication, signaling, making sure right people can join the session and they know which server to connect to. So this is what it looks for us, but then essentially on top of that, we have connected our AI infrastructure. So from the SFU, we have transcription agents for every track that take the audio and pipe the audio, the transcribed audio to AI services. From the, we have a clip generation engine that pipe video clips to AI services. And then, of course, the chat messages are forwarded directly there. This is, of course, like a super simplified view, especially like the AI services. In reality, it looks more something like this. We have, if you're really fast, you might see that we are using GetStream for chat, and we're using LiveKit as the SFU provider. So we're here to talk about real-time. So let's talk about the real-time aspects of these features. Latency is extremely important for any feature that accompany a live experience. If something is too late, it's not relevant anymore. So this is sort of what we see as sort of good targets for our features. If you do some sort of voice command, you need to see an action within a couple of seconds. Otherwise, you're going to believe the feature is broken and you're probably going to start to repeat yourself. For understanding chat messages, I think we have a little bit more time to play with, whether something is this a good question or not. So we can probably extract something up to 5 seconds. For video moderation, it is a trickier area. If you really want to sort of immediately know if someone is appropriate or not, that probably has to happen within 5 seconds. And I don't believe the technology is really there yet. From what we heard today, I think like if you do using a cloud-based LLM for video, it's sort of similar to where transcription was 10 years ago, that you upload this file and when the file is analyzed you get the result. And there's a lot of sort of copying that has to happen, which is sort of unnecessary. You have to write the file to one place and upload it and then wait for the result. So there's a lot of optimization that can happen there, or probably will happen within the coming years. What you can do instead then, you can try to build a user flow that allows for a bit higher latency. For example, if you have several speakers in queue waiting to join you, you can analyze this video while they are waiting. Or you can also choose to let someone come with audio only and then having the video blurred for 5 seconds or so before it's checked. For fact-checking and supporting information, it's very important that the discussion has not moved on to something else. So you probably need to bring that information up within 10 seconds or so. And then for the post-produced features, it's not really relevant here. So I'm going to dig a little bit deeper into what we do to keep the latency as low as possible. And hopefully this can help some of you as well when you're building real-time AI features. And this is all in the context of us being a small company with limited resources. We have roughly 10 engineers on the team. And of course, we are relying a lot on external infrastructure services to build a complete platform. One of the key things is that you need to have a flexible LLM architecture. Right today, we are using a mix of GPT-5 Mini, GPT-OSS, Llama 3, and Gemini, and some of these actually run in different environments as well, depending on our need. First of all, this requires you to always take advantage of the latest development. When something new is coming out, if something is cheaper, faster, better, you can immediately move over to that. But I would say even more importantly is that this allows you to optimize your service by using the smallest possible model that essentially is good enough quality for your feature. Of course, you also need to know how fast they are. We use a framework called OpenRouter. We use it for reliability and redundancy. But the good thing is that they also provide actual user statistics on the provider latencies here. A nice thing is that if you use the smallest possible model, you also use the cheapest possible model almost always. But there is also sort of a flip side to it. You can make things go faster by paying more money, and that is by using the hardware accelerated models. We are using Llama 3.3 and GPT-OSS by a provider called Cerebras, which has built dedicated hardware to make LLMs really fast. Then lastly, today the existing reasoning models are just too slow to use for real time. Basically, you have to do the reasoning for it and decide on forehand what potential context that might be needed. I mean, if you're using GPT-5, maybe reasoning models is too slow for doing anything nowadays, but that's a different thing. Yeah, having fact-checked as an example, right? You have to see, this is a statement, should it be fact-checked? If so, get information and summarize things. Then, of course, you need to make sure that you have a low latency infrastructure for your services. This is, of course, going to be different platform by platform, that this is what applies to us. our AI services run on a microservice architecture, and we're using Kafka as the main event path. We have a Python backend, and using Kafka with Async I/O, gives us very low latency. This depending on that you are able to process as many messages as possible in parallel. All the data can't go in the Kafka event though, so we use short-lived database entries for additional information that might be required as context. For these fields, it's important to take into account that you can allow some entries to update slower. For example, when we're using chat data as a context, not analyzing the chat directly, we only update it once every 10 seconds, which is fine for that purpose. But of course, that would not be okay if you want to analyze a chat message directly. Then, last of all, you cannot improve or you cannot measure, as to say. So having some sort of end-to-end tracing is crucial. You need to see what time is spent where. And I'm going to give some examples of that. So this is some example from our tracing. We're using Sentry right now, but we're looking at other options. I'm not saying go use Sentry. So I'm going to use FactCheck as an example here because it's probably one of the most complex features timing-wise we have. All of this starts with a separate service called Soundbite, and all the Soundbite service do is to extract important and meaningful statements from the speech. In that process, there is also a tag whether something is potentially fact-checkable. If that's the case, it's then going to get moved on to our next service, which does the actual fact-checking. When that happens, we perform a much more complex and longer query, trying to determine, is this something that actually should be fact-checked? That's where we're trying to rule out, is this just an opinion? Is this a subjective area? Things like that. If this is still true, and this should be fact-checked, that's when we fire off several web queries in parallel to gather the information we need. This is target sort of reliable sources like Wikipedia and news media that we trust. And lastly, all of this is put together into first one short summary, but then we also provide a longer answer that gives you more context and also provide all the sources we use to get to this answer. I want to end with talking of what sort of we see more as a future area and what we're working on right now. We also seen several examples of that today, and that's to leverage video understanding more. As I said, we already had the infrastructure to do this for moderation, but we see a lot more opportunities here. One area is what I call the auto producer, which would be a much smarter way to essentially provide the optimal video layout, so decide how much screen area should be used for what and how to crop the videos in the right way. Basically trying to make the live experience look as good as a post-produced video podcast. Then we also see a lot of opportunities in shopping. Instead of sort of a traditional TikTok model where a creator is pushing a certain product or line of product, we can automatically highlight things for you. For example, someone is wearing a cool shirt, you can immediately know where you can buy it. Someone has a cool painting in the background, we can also surface that for you. Then we also see a lot of interest from the creator we're working with to use it to sort of engage the audience. This could be example, let's say you're a yoga instructor, you could easily run, quickly run a competition who has the best yoga posture, who can do the most push-ups, things like that. So I'm going to end with a demo we did as a proof of concept for this. This is not in our product yet, but it's essentially, it's running 100% on a real infrastructure. It's just that we sort of hard-coded the feature instead of building a UI for it.
Okay, let's do something fun. I want to see who the most fashionable person is. So guys, if you have any Chanel items, go and grab them and come show them off. Let's start a competition. The winner is going to get a discount code to Chanel. So I can see on the right that the AI is looking at your videos. I see you holding up things, but our AI is going to analyze the videos to see who's got Chanel and who's just holding up something random. All right, we've got our winners, Omer and Nini, I see at the bottom. So I'm going to bring you up on stage to show off your items and to verify that they are actually Chanel. Hello, Nini. Amazing, beautiful Chanel bag. Omer, I sent you an invite as well. Incredible, that is a Chanel perfume. Congratulations to both our winners. You both will be getting discount codes. Thanks for playing.
Cool, thank you very much. I think the takeaway should be that, it is possible to build AI features today that interact with you in real time. And now is the time to do it.
Does anyone have any questions? I am particularly curious about the technical details about the last feature that you said that it's not yet released. I believe that some VLM work has been done. Can you share some details about that? In particular, what models did you use for that?
This is running Gemini because it is very strong on video understanding. So basically what we do is that we trigger that we are recording clips on all the video tracks. And right now it was given a prompt to recognize Chanel items. By chance we were doing this at an investor event where we had some Chanel owner family there as participants, so it wasn't a chance we chose that. But it's simply that's what it is.
Did you find any particular objects that it struggles with, or across the board, whatever you feed it with, it was okay?
No, I think it is like always. If you give it something very, very specific, you get a good answer, right? You cannot ask, what is the best, who looks the best, right? Sure. There is a lot of prompting, and if you want something more subjective, we saw some other example here. You have to essentially ask them, we want you to rate this image on these 10 different axes, right? And you get the score of that, and then you essentially have to build your own logic based on one factor to see, and that's how you tune the performance. Yeah.
Okay, thank you. In the back, Chris.
Hey, good talk, man. Thank you for doing that. It seems like you've built in a lot of these really cool AI features for kind of a creator economy type app. How are you guys evaluating like the cost of operating such a thing, especially when you're dealing with so many models in the cloud and services, which definitely eat up GPUs and cost a lot, versus like what consumers are willing to pay for this type of service?
I think that's a very, very relevant question. I would say right now we are not super worried about the cost, because we believe, we see how they go down quickly over time, and once you build, a really compelling experience, there's lots of things we can do to optimize them. That said, for our typical use cases, even now when we sort of just brute forcing things, it's still the video infrastructure is more expensive than the AI infrastructure.
Thank you.
Any other questions? If not, thank you, Niklas, for your talk and being here. Don't forget to scan the QR code. And yeah, this moment had to come. Last talk for today and for this edition of Rtc.On. But last year we did the same playbook. Ali Sibegen was the last speaker, and it was a great choice because it's a WebRTC kind of a conference, but it's a little bit of irony to end up this type of conference with a beautiful roast for WebRTC, because Ali is going to be talking about media over QUIC. I guess that he might even send some mocktails to us. So, Ali.
All right. Good afternoon. Thanks for staying all day for this last talk. My name is Ali. I am with Özyeğin University. I was at Cisco for about 9 years after doing my PhD. And then I've been consulting since then for the last 10 years. And I'm also a computer science professor. So today I'm going to talk about mock. Yesterday Will gave a good overview of what has been happening with mock. You are going to see mostly some demos and some working implementations. And our implementation is called Mocktail, and that's what I'm going to show you today. So as a recap, a lot of people probably know this, but some still seem to be struggling with. So QUIC is really like a multi-lane highway. There are multiple streams within a QUIC connection. So you need to open a single connection with the server or another peer, but then there can be multiple simultaneous streams ongoing between the server and client. So this could be peer-to-peer or a serverless client. So let's say this multi-lane highway, single QUIC connection, but 3 streams are shown here. There's also datagram mode, so you can also send some unreliable datagrams over this connection. So on the sender side, we have, the whole QUIC stack actually runs in the user space, so it's not really part of the operating system. So it's part of the Chrome browser, Safari browser, or Firefox, and so on. So it's within your application. So it's, everything is in the user space. That allows us to customize the congestion control and retransmission machinery if you want to for our specific application. So there are 3 streams in this case, and then streams can be prioritized relatively to each other. So high priority stream could be your text messages, your audio messages, and so on. Medium priority could be like your screen share if it is a video conferencing. And then low priority could be like file sharing or video streams and so on, right? It's all up to you. And streams support, they guarantee that the delivery will be in order. So packets are going to be sequenced and the delivery will be reliable and in order. But there is no in-order delivery among the streams, obviously, because high priority is going to make to the client way before than the low priority stream, obviously, right? So you got to make sure that you can handle that in your application. And then this is all a single QUIC connection, and who knows how many streams there are within a single QUIC connection. It's not going to be transparent. It's not going to be visible to the ISP or the network provider. So everything is going to be transparent. So if you need some sort of quality of service, I want to prioritize my stream 2, which is my screen sharing, for example, in this case, well, you got to actually use a separate QUIC connection. Your ISP otherwise won't be able to do anything for that. Now, with mock, what we are trying to do is we would like to separate the delivery plane from the control plane and the media plane. Right? In WebRTC, they are all intermixed, and then that's obviously makes things a bit more complicated. So we have lots of different applications, and I'm going to show you some here. So on one hand, we deal, when we focus about, when we care about scalability, Dash HLS obviously comes into mind. And today, YouTube, Netflix, all kinds of those platforms, they use Dash HLS or a variant of it, right? And scalability is pretty much unlimited. Like the more CDN edges you add, the more scalable you are going to become. And then the same thing for live streaming. So today, Olympics, World Cup, or Wimbledon finals, and so on, they can be streamed by millions of people without any problem in 4K. So that's not an issue either. Low latency extensions for Dash HLS, they both exist, and then they can be used. But we haven't really seen much traction on that front, to be frank. The specs have been around for over 6-7 years now, but and there are really good implementations, but the market hasn't really picked up yet. For interactive live applications like betting and gambling, that sort of thing, many companies or many content providers or owners, they seem to be relying on WebRTC or some sort of it, right? And with interactivity, obviously scalability usually goes down, and if you want more scalability, you need to give up on the interactivity and so on. What MIDI over QUIC, we have 2 types of transmission. One is on the, on the interactivity side, subscribe, pops up model. And then on the on-demand side or live streaming side, we have the fetch support, which I'm going to show you today. This has been added to the spec in the last year or so, and allows us to support Dash or HLS type of applications. So the entire protocol is still a single mock transport, but it can work seamlessly into different modes. So one nice thing about mock is, it is latency tunable. So on one extreme, you have WebRTC, which really don't have any tuning mechanism for latency. You just you might have a small play-out buffer, but that's about it. The transmission doesn't really know anything about that. It's on the client side. For VOD, your buffering could be in the order of 45 seconds or even a minute, like Netflix. And mock can do both. It is quite quite a big feature of the protocol itself. So on one side, we have publishers, and on the other side, we have subscribers. And then if it is a video conferencing, obviously a publisher will be a subscriber as well. So media sources, they are individual publishers. They send the data. There's also a control stream where you send all these subscribe, unsubscribe, fetch, and other control messages back and forth. So that's a bidirectional channel, and then media goes only in one way. The same application can be run on web transport if you are in a browser environment, which currently what we support in Mocktail, but raw QUIC implementations are just straightforward. So Mock is about scalable and really, really highly scalable distribution, and it is really a generic distribution. Mock doesn't know anything about the media it's carrying. Whether it could be audio or video or text or image, it doesn't really care. So there could be all kinds of different applications where you can think of IoT devices and so on. So security cameras, drones, and things like that. And they could be publishers. And then at the same time, a bunch of databases or monitors or speakers or human beings or some other devices could be the subscribers. And this could be, again, a two-way traffic. What is important is that we have a generic mock CDN in between, and then this could be multiple CDNs. So I'm hoping Akamai will be one of them, Cloudflare will be another one, and so on. So you can actually buy these services, CDN caching capabilities from all these companies to scale your application. You don't need to deal with like SFUs and so on, as you will do in WebRTC distribution. Okay, yeah, so you just focus on the publishers and subscribers in your case. Now, why Mocktail? We started developing this, earlier this year. You will remember that I showed a couple of demos last year, and then, in this conference and in some other conference, I've shown some other demos, and they were all based on the initial implementation based on mock.rs. That code base was not ours. It was, from Luke, who used to be attending the ITF meetings and so on. But later on, you might know the story. He kind of diverged from the ITF process, and then he started implementing things in the way that he wanted to. So we said, okay, we want to stick with the ITF process. We want to stick with the ITF spec and so on. So we created our own implementation from scratch. So also, just because you are compliant to the spec doesn't mean that everybody is going to be able to use your software. So we are trying to make it as easy as possible for people to experiment with this and then develop whatever application they would like to. So our current implementation stack is as follows. So at the bottom, we have web transport. And then if we are running in a browser, like publisher subscriber wise, we will just use the API provided by the browser. And most browsers today support web transport, but the leading browser is Chrome. And we have this W-transport crate for Rust, for the relay, and then QUIC crate for our QUIC layer. That's also open source. So the web transport crate and the QUIC crate are not ours. We are just using them, and they seem to be quite popular. And Mocktail is what we are developing. So for the publisher and subscriber, we have Rust components as well as TypeScript components. And the relay, which is generic again, for whatever application you are using this relay for, it's going to be the same, and it's implemented in Rust. And on the top layer, until 2 weeks ago, I used to have only LOC, so low overhead container, which is the basic, very simplistic container format for media. So it uses web codecs, right? Audio framing, video framing, and so on. It's a very simple header mechanism, and it allows you to carry all these audio, video content. Now with CMAF, which we implemented in the last month or so, as you know, CMAF is the main streaming format for Dash and HLS. And just this morning I learned that the CMAF spec coming out of MPEG has won an Emmy Award yesterday. So the celebration will be in February, but the news just came out this morning. So congratulations to all those who were involved. This work actually started in MPEG in 2016, so almost 9 years ago. So we have a lower overhead container. We have, for the client side or for the publisher and the subscriber, we have the TypeScript components that support that, and then it uses web codecs API from the browser. For CMAF, we have Rust on the publisher and connected to an FFmpeg instance. And then for the playback, we have TypeScript and media source extensions. So it is demo time. I'm gonna invite Zafer, who is one of my PhD students and who has been the main developer for this project. So we are gonna have multiple demos, and pretty much all of them are online. I hope they were just working like 10 minutes ago. I hope they're still functional. So let's go one by one. This is what we showed just a couple of days ago in IBC. We started this project a month ago in mid-August, and Will from Akamai, and then Gwendal Simon from Snemedia. We have been a big proponent of the fetch mechanism. So not just for real-time conferencing, but also all these streaming type of applications, we should be able to use fetch, mock, right? So we thought that we should actually have a demo based on this mocktail implementation that we have, and it should really enlighten people, and educate them how mock could be used in practice. So what's happening here is that I'm going to show you the demo, but here's what's happening. We have a live game, right? And then it goes through an encoder, in this case we use AVC, but you can use any codec FFmpeg supports. And then this company from Portugal, 6th Floor Solutions, they have this nice product, I will say. So they get a feed of their live video, when the game is being played. And then they have this real-time AI detection of different events. So in a basketball game, it will be like a 1-point score, 2-point score, 3-point score, falls, plays, steals or blocks or slam dunks and so on. Whatever they can generate based on the real-time video, they send us some sort of metadata, and this metadata comes into our publisher, which has been implemented in Rust, and then also gets the elementary streams from FFmpeg, creates the mock groups, subgroups, and objects. Every CMF chunk is a mock object in our implementation at the moment, and that's only one frame. So we try to achieve low latency here. And every GOP, like a CMF segment, is going to be a mock group. So we have all these objects being published in real time, and then we have a relay, and then we have a subscriber. So this will be you on your browser. You will go to the website, ibc25.mocktail.dev, and then you are going to open a connection to the relay because you are getting a catalog which is going to explain to you what's available, in what codec, in what resolution. Just note that there is a single video track in this case, so there is no rate adaptation, but it's just a straightforward extension to this application. So in this demo, the main thing is this timeline events associated with the video, real-time audio and video, and everything is being published, and then the client is going to subscribe and it's going to receive all that information. So this is one quick connection. This is another quick connection, and I'm going to show you a demo. It's going to make it clearer. So let's see. So at the moment, we have two relays, one in Europe, in Amsterdam. And you can see the latency, the ping time, 54 milliseconds from here. And then we have one in Chicago. That's on the other side of the world. And I'm going to pick that one just to show you. Oh, all right. Well, that's interesting. I thought that I was just I want to share the entire screen. That's what I did. Okay. I need to exit from the PowerPoint. Sorry. Here we go. All right. Thank you. So we joined the game. Obviously, this is not a live game anymore. This was played in Portugal some time ago, but we are feeding the information to FFmpeg just like it was. We are pretending that it's live. So it's live encoding and then everything, and so it's so on the top you see media time. So it has been like 9 minutes 22 seconds since the game has started. So after a couple of hours, when the game ends, it just loops. Publisher time is the local time in where the publisher is. I think adjusted to our time zone, right, Zafar? Right. So subscriber time is our time, my computer's time, because that's my my player, and the latency is the difference between those two values. Now, you are gonna be able to see the settings over here. So let's see. The default latency is 1.5 seconds, as you can see, and the latency tolerance is 0.25 seconds. So as long as the latency is between 125 and 175, the player's okay. But you can change those settings, which I'm going to do now. So I'm going to reduce the latency to actually even 0.6. So what's going to happen is that you are going to see the value. So it should come down to, it should be around 335 and 0.85. So, and remember, this content is coming from all the way from Chicago. So that's already some network latency, right? So the latency we get is less than half a second. So which is pretty good. The way it works is that it tries to achieve the target latency. And if you, for example, I'm going to increase the latency a bit now, just to show you that. Let's say to 1.6. It's going to slow down the playback. So instead of playing at 30 frames per second, it's going to slow down to maybe 26, 27 frames per second for a while. So it will actually fall back behind the live edge. If I want to get closer to the live edge, it's going to increase the playback rate, so frame rate. Instead of 30, it's going to play at maybe 33, 34 for a while, and then it's going to reduce the latency. So you're not going to see jumps. It's going to play a bit more, a bit faster or more slowly, but you are going to get there eventually. So you can also adjust this playback speed catch-up rate. So 0.9x and 1.1x, that means only 10% faster or slower. You can make it larger or smaller as you like. Now, the interesting thing, I mentioned that this real-time event detection. So these are 3 points. You can filter the events as you like. Let's say I want to just see the 3 points. And this is the last 10 minutes, by the way. So this is a live broadcast, but we give you the capability to rewind to a point of interest based on your interest, right? So I want to see this 3 point. So it wasn't being fetched so far? All right, let's see. That should come a bit faster, but so this is the replay. So this is going to be a 3-point shot, right? So the live broadcast is still going on over there, and then this was a replay. So if there's another replay, for example, let's see another 2-point. So let's say you were watching the game, you went to the bathroom for like a 5-minute break, and then you come back, you want to see all the scores, all the shots that you just missed, right? You can open as many as you like, depending on your, bandwidth. Each of these are 2 megabits per second at this point. So video doesn't look very good because that was the only source video we were allowed to use in this demo. That's 2 megabits per second. And whenever I want to go back to the live, I just come back here and promote this, and then I can replay at the same time and watch multiple feeds at the same time if I want to, right? So all these different events. Unfortunately, these 2 teams are not very good, so there are not really that many scores, but it is what it is. So the latency is quite minimal, all the way from a game in Chicago. Let's pretend that because the publisher is in Chicago and we are in Europe, Krakow, that's already pretty good distance, and 0.6 seconds is easily doable. One of my other students who lives in Vancouver on the West Coast, he was able to get a 0.1 second latency from the same publisher, even like with all the fetch capabilities and so on. So the live feed is again pops up, subscription, and then all these replays are based on the fetch. But it's the same QUIC connection, and they are all prioritized accordingly and so on. For example, in this case, we give the highest priority to live stream because we don't want to pause the live while we are trying to replay something, right? But in your use case, it could be something totally different. Any questions before I close this demo? Yes?
Does audio work?
Huh?
Does audio work?
Yes, it does. Yeah, it's just not here. Yeah, okay. I mean you can hear or do you speak Portuguese?
No, I don't. But
Okay.
I just wanted to see that everything goes mostly with audio.
Yeah, there's audio. Yeah, there's audio. So.
Mais alguma alteração? Não, para já agora.
And speak Portuguese here?
Sporting já com muitas mexidas no seu ciclo. Penso que totalista de...
What's that?
They're talking about the game.
Yeah, okay, so that's good, right? So one nice thing we implemented, unfortunately, we weren't able to show in IBC because of all the noise in the in front of the booth. So whenever you are playing multiple videos, obviously you don't want to play the audio from all the sources at the same time. So what my student was able to do was whenever you want to hear a specific video audio from a specific video, you just hover your mouse, your cursor to that video, and then the audio will just come from that, and the others will be, almost muted. So, I mean, it doesn't really make any sense to us because none of us spoke Portuguese, but I hope it worked. So, any other question before? Yes.
Is it over the same QUIC connection or
Single connection? Everything is happening. So obviously it's a UI issue, but you can open as many as like 16 replays at the same time with +1 for live. So, and everything, and remember that's a catalog track, which is your like playlist and so on. There is timeline track, which is broadcasted every 1 second. So as soon as a basket or a fall or 3-point happens, it's gonna show up here in 1 second, right? That's another stream. So audio, video are separate streams. So it's like, there are so many streams going on in parallel here, but they're all within a single QUIC connection, so that we can prioritize accordingly. If they are in different QUIC connections, there's nothing you can do. They're going to be running independently. So that's not what you want. Yes? Yes?
If you change the latency, so in video we saw that it accelerated or it slowed down. If you have audio going on at the same time, are you also speeding it up and slowing down to synchronize?
Yeah. So, I mean, if I do this, it's now 10%. So 10% is more like borderline 6% for normal people. I mean, if you are quite picky, you are going to even notice like a 3%, 4% slowdown or faster playback. I mean, I can, but my parents cannot. I mean, it depends on the audience. If I increase this to, let's say, all the way to 50%, that's going to be crazy. I mean, people are going to be running like this, or they're going to be running like this. It's not going to be much fun. But that will allow you to catch up faster, right? Obviously, because your variation is larger. And with audio, 50% sounds a bit funny. Yeah.
Hey, Ali, I was actually going along the same lines.
Oh,
but,
okay. Yeah.
As a musician, that would drive me nuts listening to music, right?
This is not music. It's
no, I understand.
It's Portuguese, so we are okay.
Não é música, é português. Yeah, got it. But you could conceivably just shift, right? And so like in a music application, you just say,
yes,
I want to just seek directly to the latency that I have and just have it skip. Is that like the technique you would use for that?
So our algorithm is not very sophisticated, but there is also that feature. So if you are, let's say, sometimes your connection or your Wi-Fi is going to suck, right? You are going to be at a latency of, let's say, 20 seconds because you were going under a tunnel and then your connection kind of stalled, so you didn't get any new frames, right? So in that case, when the connection comes back online, the client is going to see, hey, look, my target is 0.5 seconds, but I am 20 seconds behind now. And there is no way that I can catch up to this. So I'm going to skip all the way those 20 seconds. I'm going to be within like half a second range of the current live edge. Yes, we have that logic as well. So, but it has to be quite behind the live point so that to trigger that, because you don't want to really jump the content unless it's really necessary, right?
Like I said, if it's music, then you care.
Yeah.
Unless it's music where it's going to really disturb the experience by having it, speeding up.
So the key word over here is pitch preserving audio playback. I mean, for video, it's not really that important. I mean, looks like there is some playback frame rate variation right now. But as long as you reserve the pitch, the humans will still sound like humans. So guys are going to sound like a guy, not like a female person. But for music, I think that 6% threshold is even lower.
Well, I mean, the reason I bring this up is we did this exact same thing with WebRTC back in the day, and our clients who were doing concerts and stuff, they hated it, right? And it became a real problem. So we had to basically turn it off for the certain use cases,
Yeah, exactly. So, I mean, that part has nothing to do with mock, obviously. It's just a player logic. But the idea over here is, so it looks like my latency has increased a bit. So I don't know what it was. Okay, it's still within the target. So if I increase to, let's say, 3 seconds, it will slow down the playback. As you can see, the players are slower. Now they are back to normal frame rate again. I think there was another question. Yes?
Yeah, I had a question about
the mic.
Sorry. My question was about the timing measurements that you're doing up there.
Yes.
And I was wondering how you're carrying out the publisher time, subscriber time, and media time in the packaging layer that you have shown us.
Yes, very good question. So subscriber time is just my local time, my computer's time, right? And we expect my computer is NTP synced to timeapple.com. And Will tells me all the Linode service where our publisher is running, they are also very strictly synced in terms of time, NTP synced. So we should expect they are more or less the same, right? They are on the same page. Now, media time is just how long it has been since we started the game, right? So like from frame 0. So that's actually inserted by FFmpeg. And publisher time is also something inserted at the FFmpeg using the PRFT box, producer reference time box. So that's actually an MP4 box where you can put different versions of time so that information is going to be carried all the way to the client. And in this case, it's going to be end-to-end latency because that's right after encoding. Actually, this doesn't include the encoding time, which will say, let's say, another maybe 30, 40 milliseconds. So you can do it before encoding, after encoding, before packaging, after packaging, before the publisher, after the publisher, before the relay, after the relay. So you can actually print out the whole, where the latency is being spent, right? So that the box you are looking for is PRFT, but that's a CMF MP4 stuff. So you need to do some like RTP header extension or something like that for WebRTC to get the same thing. Yeah.
Hey, thanks.
Sure. Any other question?
I have one more question. I'm here. Sorry, on your right. Here.
I can see you.
Here.
Oh, okay.
Do you happen to know how browsers currently behave with the caching of the media right now? The current implementation in regards to media over QUIC, depending on, I don't know, for example, the playback segments seems something like the browser could cache. I don't know if that changes depending on the protocol here.
You know, whenever, let me show it to you. So actually, let me just automatically close all the replays. So whenever I click, I mean, usually these two games really suck. I mean, there is no anything at all on this time period. But let's see this 3-point shot. So this stuff is currently coming from the relay stuff. It wasn't cached at all, although maybe it was played in the player like a minute ago, right? So it's not cached at all. So even if I go to this event, let's say this happened like 23, 22, so just a while ago, just a minute ago or so. So this is also coming from relay. So we don't cache anything on the browser at the moment. Do you think we should, or? I mean, we don't, I mean...
I thought that the browser maybe would cache some stuff automatically, like, and maybe with HLS, I guess.
Well, some certain, you know, static content might be cached, obviously, some segments. But in this case, this is purely coming as a mock object, so there is no way for the browser to cache, right?
Okay.
There's not. Yeah, there's no caching.
Okay, okay, thank you.
So even if you just missed a second ago, you want to fetch, and then it will come from the relay. And I guess that's something the content sports providers want, because they don't want any copying or pirated content being rebroadcast and so on, right? All right, last chance for any questions. No? All right. So this is it. The second demo. This is something we implemented the first, the first demo we had, and then we showed this in Berlin in MediaWeb Symposium, and then later, a month later in July in SVTA segment. So this is going to be a video conferencing, and Zafer is going to join to this. Let me. So this is also open to anybody. Demo.mocktail.dev. So I'm going to type my name. And then we are going to give a room name, just like you are joining a Zoom session or WebEx session and so on, right? So this is me. I am waiting for someone else to join. And Zafer is here, right? So let me turn on my camera. Okay. Okay, let me stand here. So, so this is like, this is a demo room. And as you might guess, we are paying for AWS for this, so we limited the number of users in a single room to 6, and limited capped video bitrate as well, because we are paying for the outbound traffic. But Zafer's traffic is going to the relay and then coming to me, and then my content is going to the relay, and this relay is in Frankfurt, right? So in Frankfurt. And then it's going to his computer. So there could be someone else joining, and then it could be the same thing. So the latency, I see from Zafer is about 100 milliseconds, so that's about 2-3 frame, 3-4 frames cycle. So there is audio, there's video, you can share your desktop and do all kinds of things. There's chat, there is support for emojis. What else you could want, right? But here is the nice thing. So let's say you were in a conference call with your boss or with your advisor, and then he asked you a question and you weren't really paying attention. Maybe you were visiting another website or watching Netflix. So there's a little blue button here, which is rewind. So what you are going to do is that, Zafer, can you count to 1, 2, 3, 4, 5, and then I'm going to rewind. And then let's confirm whether Zafer has counted correctly or not. So this will be just a rewind window with the audio as well again. And while the conference call is still going on, you just you are just able to review what your boss or advisor had to say, right? So, and then this is last 10 seconds in this example, but we could do all the way back, or we can have a similar timeline here since the beginning of the conference call. So you can scroll, and see what people had to say, right? In this case, obviously, we are not really rewinding the entire conference call. That will be something different, but you were interested in what this guy had to say, so we are just rewinding that person. And same thing for his screen share or for his video and so on. So this allows you, I can replay it, I can close it, and then if I rewind again, it will be the last 10 seconds again, and so on. So this is really like, what we call video conferencing with time travel. I know it sounds really fishy, but it is what it is. Any questions here? This is the video conferencing side of Mock that, many people actually had the vision for. Oh, Mock is going to replace WebRTC. This is what we are going to have. The first demo was streaming. This is video conferencing.
Yeah, Ali, are you trying?
Oh, okay. Yeah, sorry.
Are you sending the chat over the Mock
yes.
data channel as well?
Yes, yeah.
There are 3 tracks, audio, video, and chat tracks.
Yeah.
Same connection.
We are going to separate the screen sharing, but yeah, you get the idea.
You had the video tracks and the chat, the text chats as separate track.
Yeah.
Very cool.
Yeah. And then we are going to separate the screen share. Right now the video is it's 200, 300, or maybe 400 kilobit per second. You can see all the statistics here, like looking at the codec and the resolution information and so on. And, okay, we have someone who showed up and then just left the call. Yeah. So we are going to make the screen sharing a bit higher resolution so that it looks clearer on the screen and so on. Again, there is no rate adaptation or simulcast in this case, but that's just a straightforward extension to this.
I have another question. I'm here on the right.
On the right, yes.
Yeah. How it behaves under a poor network, and are there any advances in the congestion control in the browser?
Yes, well, the congestion control is going to run on the sender side, so you can just you are able to affect how your traffic goes to other users, right? So there are a couple of things that we have done, and then also we plan to do. So let's say my connection is very poor, right? Maybe he has a great connection and I have a poor connection. Obviously, I may not be able to receive his traffic, and maybe more importantly, I will not be able to send my traffic, right? So in this case, maybe I'll just cut off my video and then send audio. Or since audio is higher prioritized than video, it should actually work that way anyway. Maybe I'll stop screen sharing, and so these things are prioritized at different levels, right? So the sender is going to do its best to send the highest priority traffic to the other side sooner than the others. But even if you don't have bandwidth for that kind, to be able to send that, well, they are going to be dropped because the sender is going to understand that this is the latency budget that I was given. Since it's already past deadline, I'm going to skip them. I'm going to drop them, right? So you can cancel those QUIC streams and then start a new QUIC stream once your connection comes back online. So.
Yeah, but is that only, the granularity is only that I can just stop sending the stream or start sending some stream? Or can I, for example, if with WebRTC, when some frames don't arrive, can I just forget about them, or they are already transmitted because of the congestion control, which forces retransmission of all the frames?
So in this case, we are still using QUIC streams, which again, as I said, support in-order guaranteed delivery, right? But as soon as I understand that the rest of the frames in that group, in that let's say 5-second group, are not going to make it, right? Because it's going to be way past their deadline. I'm going to cancel that stream, meaning that I'm going to drop all those frames in the ground, and I'm going to continue with the next group, which will start its own iframe or keyframe, whatever, right? So I can do that. Another thing is that I can try adjusting my encoded bitrate, because I am the encoder myself, right? I can, instead of at 400 kilobits per second, I can try sending at 100 kilobits per second, right? So I can do that too. All of those have different advantages and disadvantages, as you know. With QUIC, you can decide what to do, right? Just because it's still reliable doesn't mean that you need to send them anyway. You can cancel the stream anytime you want.
Okay, thank you.
Yeah. And then we don't support QUIC datagram mode yet, but if you want to send this in QUIC datagram mode, obviously there won't be any retransmission capability, and it will work just like the way WebRTC works today. You send and forget about it. So hopefully they will make it. Yeah. Any other question? Yes.
Yeah, just a really quick question. You mentioned datagrams, but datagrams, they don't support the order, right? In QUIC.
Say it again.
So you mentioned it could have been like implemented using pure datagrams, but datagrams, they don't support the order of frames in QUIC, right? So would it like add some complexity on, or
it might, yeah.
It's just like an idea, because I was just thinking the same. If it's possible to transmit video using pure
I mentioned that LOC, remember, low overhead container. So there will be some sort of framing. So at the client, you can still put things in the right order before you feed them to the decoder.
Okay,
so
got it.
You need something like that. Yeah.
Yeah, thank you.
Yeah. All right. Okay, thank you. So let's continue. Okay, this is actually the demo I showed last year in this conference. It's still up there. If you go to mock.streaming.university, this is before we had Mocktail, so that's why the domain is different. We had a paper from 2024, last year in MemSys as well. So this is where you can compare media over QUIC. And then in this case, we have client-side ABR. So the client, this is the QUIC client. You can enable or disable it. It's really a very engineering-oriented UI, so it really is not very nice. But there are multiple tracks here. And at the same time, this is low latency Dash, powered by Dash.js, something we also contributed to quite a bit over time, over the last several years. So you can compare the latency coming from the same source, and then you can see how the ABR works and things like that. Obviously, ABR is still like an open investigation. I mean, we need to look into that. I mean, we have done a lot of ABR research for Dash HLS, but there are still some things for mock. This is a new demo that was developed by another set of students over the last year. So this is synchronized VOD. So this has nothing to do with live or video conferencing or anything like that. So let's say you have a bunch of friends who decide to watch Big Buck Bunny together. And then you could be in different parts of the world. So you go to this website, you click on the share play, and then you create a room yourself, right? One of you is going to be the leader. The others are going to be a follower, obviously. And whatever the leader does in this timeline, like it can scrap back, forward, jump back, and so on, it will be fully synchronized for all the viewers. And then we are using mock for this. Obviously, you don't have to, but this was just, we wanted to show that mock can be used for on-demand content as opposed to just live content or real-time traffic. So there's an IETF draft that we wrote a while back. I think it has expired now, but it explains how things work. So we still have a lot of things to work on, not just the IETF working group or my research group, but I guess as a community, we have a lot of things to do. Like congestion response policies, back to your question, what is the best congestion response given a situation, whether we are in a video conferencing application or live streaming application and so on. Selective drop policies. So the relays are going to be somewhat smart in terms of, hey, look, this packet or this stream is not going to make it. So, I mean, it's just a waste of time or capacity to send this over, so I'll just drop this off, right? And subscriber side, like sender side or client side adaptation logic or bitrate selection logic, whatever you want to call it. And then prioritization schemes. Everybody has an idea on this. I have my own, so probably there is no single truth in this. We really need to investigate what is right in which scenario. And then scheduling strategies. Obviously, when you have multiple streams going out from a relay, how we are going to prioritize or how we are going to schedule things, right? Within a single QUIC connection, you know what to do. But among multiple QUIC connections, that question has not been answered yet. So that's it, guys. So the demo, both demos are available online, ibc25.mocktail.dev or demo.mocktail.dev. The source code for the video conferencing application is also online. We haven't open sourced the IBC demo yet, but we will very soon. We just, as usual, we saw some bugs during IBC, so we need to fix them first. And that's it. And please don't abuse the relay. I mean, we are paying from our own dime for this. Please don't abuse it. All right, thank you.
Last chance to ask Ali any questions. Dan.
Yes, Dan.
So I have a question. Sorry. The DRM, where are you with DRM and mock?
I am personally against the use of DRM for anything.
Yeah, okay. Now, when you're looking at baseball games, it's kind of inevitable.
Yes, for sports especially, right? And if we use CMAF packaging, and then I think we are going to use CMAF packaging for such applications, DRM is just going to come along with DRM, common encryption and everything. There is nothing that relates to mock itself. I mean, the transport itself is encrypted. It's all QUIC, TLS, and things like that, right? And then on top of that, you have DRM. If you want to secure your video conferencing, maybe you do, I don't, but maybe you do, then I'm sure someone else is going to come up with a solution for that. I kind of don't care. Yes, Dan.
My question, sorry, you might have already said this. I had a meeting, unfortunately.
Sure.
What was I going to ask? Oh, yes, you said about not abusing the relay.
Yeah.
Can you just switch this over to using Cloudflare's new relay that they're letting people use for free? Or are there incompatibility issues? Like, where's the stack? Where's the draft? Where's the position?
Still being recorded, right? Are we?
Yes.
Let's wrap the conference and we can have the...
That's a talk later.
Yeah, but I mean, the short answer is, I mean, Cloudflare just came up with that relay just a couple of weeks ago anyway. So we didn't really have the time to test and anything like that. But I mean, their relay is quite behind the current version. We are draft 11. I mean, the actual draft is 14 now. We are draft 11, and Cloudflare's relay is 0.7. So there are a lot of things that they relay. I mean, fetch is not supported by any other relay than ours. So I mean, ours is the only option. Now the question is whether Cloudflare is going to accept our relay to run on their machines. That's the question I still need to ask and get an answer from Cloudflare. But then otherwise, we will be more than happy, because AWS is just a big,
expensive,
yeah.
All right.
But to their credit, I mean, we got a lot of AWS free credits, so we are just spending them. But as soon as it's over, I guess we are going to be done. Yeah. GCP, Google, yeah, well, yeah. But I mean, frankly, again, our AWS server relay works way better than our Linode server at the moment. We don't know why. And Will doesn't know why either, so we are going to look into that as well. So.
Either way, when the credits will be sober, there will be no hangover, as the as the sticker says. So, any other final questions?
So please use the source code, report the bugs and things like that. I mean, we want to really make this a community effort. Yeah.
Okay. Thank you very much, Ali.
Thank you.
All right, I think that we reached the end of the third edition of Rtc.On conference. I would like to thank all of our speakers, you, the people who attend the conference. I hope to see you next year. Also, I would like to thank our sponsors, Stream and WebRTC Ventures. I would like to thank Software Mention for being Software Mention, all of the crew who... I don't know when we started working on the conference, but it's like a 6, month or so process to host 2 days of talks and 1 day of workshops. So thank you very much who got involved, and yeah, I hope we're gonna see each other next year. Thank you. Okay, so there is pizza and beer if you would like to hang out here for a moment.
Basically, I convinced myself to submit something on a topic that I had never worked on.
Really wonderful group of WebRTC insiders from the industry, and so a lot of really interesting knowledge sharing happening out there.
To catch up with other people in the industry and learn things. Obviously, I'm coming here to speak, so I want to share some information about some work that I've been doing for the last year.
Now I'm considering how to convince our backend developers to try QUIC.
Get a couple of those talks, listen to them. I think they were eye-opening.
One of the hardest presentations I ever had to do.
It's just new stuff, but getting it presented in a conference with this kind of schedule is absolutely great.